All right, welcome everyone to Earth Awakenings, and we're doing a debate event tonight. With it's going to be a debate on the Earth, the shape of the Earth, and all the ancillary topics. And it's going to be Matthew Learns and Waterworld, Jim. So yeah, just wanted to welcome everyone and let these two guys take it away. So go ahead, guys.
Hey, thank you, Gio, for letting us have your server. Matthew, for showing up, for coming to talk for a couple more hours like we did 2 weeks ago, and for everybody who's listening. I'm going to represent the stationary topographical plane through Earthside. Basically, we are told that we live in a tilted, wobbling, spinning, curvy ball, bendy ball, brought to us by a Jesuit priest, and water is held down by this magical invisible force that no one can see or explain why it happens. And something came from nothing in the vacuum of outer space while traveling throughout an ever-expanding universe at 1.3 million miles per hour, while Polaris, the North Star, has always remained fixed above the North Pole, and the stars revolve counterclockwise as long as anyone can remember. So, obviously, I think we don't live on a ball, we a sphere, planet, or globe. So, I think it's a lie that we live on a globe or a ball. So, if you cover a lie, you have to lie. You have no choice but to lie, because truth will always win. Truth will always come to the light. When you cover a lie, you put yourself in this tough situation where you have to begin to lie and use fallacious arguments and be dishonest and mislead and twist things around. The globe is a lie. John Calvin, along with Martin Luther, who stood up against the Catholic Church back in the 1500s, said this: "We will see some who are so deranged, not only in religion, but who in all things reveal their monstrous nature, that they will say that the sun does not move, and that it is the earth which shifts and turns. When we see such minds, we must indeed confess that the devil possessed them, and that God sets them before us as mirrors in order to keep us in his fear." Thanks. I think Matthew's on mute.
My fault. So just for the audience's knowledge, what we agreed to do was a 2-minute opening, 2-minute opening, then 10 minutes, then 10 minutes, then more open discussion. So yeah, thanks, Jim. So I'll start. You guys can hear me okay, right?
I can hear you good.
So I'll start with a couple of points of agreement. Scientists sometimes say things that are not true, particularly when they're making metaphysical claims about the origins of the universe. Also, I reject scientism, which is the claim that science is the final arbiter of truth. That's a philosophical claim, not a scientific claim. So I also reject methodological naturalism, the idea that only purely naturalistic explanations are valid. So those are areas where we agree. Mainstream scientific consensus is wrong about the uncaused origin of the universe. Mainstream scientific consensus is wrong about the purely naturalistic origin of life. However, just because they're wrong about those things doesn't necessarily mean they're wrong about everything. In particular, mainstream scientific consensus is correct that the Earth is roughly spherical. Here are 3 observations in support of that idea. So first, halfway through the sunset, over the ocean, the top of the sun is visible while the bottom is not. This is because the water is blocking the bottom half. Second, there are symmetrical seasons north and south of the equator. Sydney and LA are about the same distance from the equator and experience similar weather and seasons 6 months apart. Third, the full moon is a constant size all night long, which implies that the moon is a constant distance all night long. And all 3 of these observations are consistent with and well explained by the idea that Earth is a globe, while being left unexplained or inadequately explained by the cosmologies that assume a flat Earth or, as Jim said, a stationary topographical plane. Finally, it seems to me that most arguments for flat Earth fall in 2 broad categories. One, describing the supposed shortcomings of the globe model, and 2, observations on the horizon. And my quick response is just that 1, most supposed shortcomings of the globe model are merely misunderstandings of the model. And 2, looking at the horizon is notoriously unreliable due to weather conditions and refraction, especially when you're talking about differences that are tiny differences in angular size. Therefore, I would say that the evidence shows that it's more rational to believe the Earth is a globe than to believe that the Earth is flat.
Hey, I'm going to go to 10 minutes. Thanks, Matthew. I want everybody, if they want to, if you Google Earth curve calculator, there's the first 3 posts on Earth curve calculator basically say the exact same thing as far as the dimensions. No flat earther came up with the Earth curve calculator that Google would put up there on the first 3 posts. So I think we can say that the Earth curve calculator is something that NASA, mainstream science, and land surveyors use 8 inches per mile squared. So if you happen to be able to find one of these online somewhere, it's very, very good to use. I'm just going to go in my time here to give some measurements. Then Matthew and I can talk about them later on. If you get the south to the north rim in the Grand Canyon, it's 21 miles. The south rim is where you have all the hotels, restaurants. They even have a bowling alley there. If you go south to the north rim, Grand Canyon, 21 miles is 6 feet observation height. You should have 216 feet worth of Earth curve Earth curve. You have 0. There is a forest on the north side. You can see the forest easily. Nothing is moving away. The Desert View Watchtower at the Grand Canyon, the east side. If you look at the east side of it, here's a little picture of it right here. It's got a watchtower right there. It's 70 miles across there. Desert View Watchtower. There should be at 70 miles. There should be at 6 feet observation height. There should be 3,000 feet worth of Earth curve or Earth bend. There is none. The Air Highway in EYRE, the Air Highway in Australia. It's in the southern part of Australia towards the middle. It is 90 miles straight. There should be 5,400 feet worth of curve. There is none. The Trans-Australian Railroad, which I hope my good friend and I can talk about a little bit later. The Trans-Australian Railroad, 301 miles. Here it is right here, just a portion of it. 301 miles. It's straight. You should have 11.42 miles worth of Earth curvature over 60,000 feet, 11.42 miles. There is none. The FE Core laser test in 2018, over 25 miles, 40 kilometers. One laser was at a 9 feet observation height. The other was a 6 feet observation height. It was experiment 7. There should have been 273 feet with the Earth curve. The lasers saw each other. The Utah laser test in 2021, I believe it was in April. It was a 34-degree day. 18.8 miles. You had a 6 feet observation height on one laser, 5 on the other. You should have had 145 feet worth of bend or Earth curve. You had none because the lasers could see each other. Radar on the ocean. If you have radar in a ship, and let's say you have it up 100 feet into the ship, you can look out at something 60 miles away, ping it. At 100 feet observation height, you should have 1,520 feet worth of curve. Laser was built line of sight, straight line. So if you had a bend, as the Loon McToon likes to say, it didn't go off the ionosphere and come back down. It doesn't work on a ball. There are over 170 bridges in this world that are 3 miles or longer. There's 10 of them that are 22 miles or longer. 22 miles or longer. There is no Earth curve built into those bridges whatsoever. You have from Benton Harbor, Michigan, to Chicago, Illinois, 62 miles across. Here it is right here, my friends. 62 miles across at 30 feet observation height. There's lots of hotels there. 30 feet observation height. There should be 2,038 feet worth of earth curve. If you're at 6 feet on the beach, there's 2,321 feet. But if you're 30 feet up in a hotel, there should be 2,038 feet worth of earth curve. And the geometric horizon, according to the earth curve calculator, should be 6.47 miles. But you can see across on a nice day, not every day, but on a nice day, you can see 62 miles across. In fact, on sometimes during the summer, because it's facing east to west, you can see the sun moving away behind Chicago. My friends, the Sears Tower or the Willis Tower, which is in Chicago, it's the same building, is 1,450 feet tall. With the antennas, it's 1,700 feet tall. You can see all of Chicago from 62 miles, 30 feet observation height. The geometric horizon, we are told, is 6.47 miles. You can see 62 miles, which is 9 times further than you're told you could see on a ball. Think about that. 9 times further than you're told you can see on a ball. We'll talk about what the globe pushers, the globe advocates, call that for a reason. We'll talk about that in a little while. I-5 from San Francisco to L.A., 383 miles. There should be over 18 miles worth of earth curve. There is none. There was none in the construction, none in the engineering, none in the blueprints. Should be over 18 miles worth of earth curve, over 383 miles. There is none. The Suez Canal is 102 miles long. 102 miles long. That should be 6,900 feet worth of earth curve. If you notice, there is no curve in the Suez Canal. It is flat. Just to give you an idea, here's the picture of Benton Harbor looking across the Chicago. Just to give you a little idea. Here's this clown that I had the I was fortunate to talk to on Facebook back in January. We did because we were talking to each other during the halftime of an NFL postseason game. We both commented on that. Plus, we talked a lot more than that. Tom Coombs, he's the meteorologist at ABC 57 in South Bend, Indiana. And what he did was he saw all of Chicago. I want this to sink into people. He saw all of Chicago from Grand Mere State Park, 56 miles away, which is just a little south of Benton Harbor, Michigan. And he had to come up with an excuse of why you could see all of Chicago, like he put on his TV program. You see all of it right there. You see it? He had to come up with an idea. You know, the idea, I think a lot of you know, he came up with a mirage. Bendy light, folks. Bendy light. If you know anything about this effect, you get light going through molecules. They do not bend. They change direction. If you get light going through a molecule, whether it's the top part of the molecule, bottom part of the molecule, sides of the molecule, they will stay straight. They will change direction, but they will not bend. So Tom Coombs could not go on TV and go, well, the earth is flat. He couldn't do that. So he came up with a mirage. Mysteriously, all of Chicago was supposed to be gone, but mysteriously, the mirage or refraction picked it all up so you could see it like that. My friends, we don't live in a cartoon world. We don't live in a fairy tale. We don't live on a ball or a globe or a planet or a sphere. The reason you believe you live on a globe, planet, whatever, is because you were told at 5 years old that you did, and you never grew out of it. You grew out of Santa Claus. You grew out of the Tooth Fairy. You grew out of the Easter Bunny, but you never grew out of your ball. Shame on you. You never grew out of your ball. I can't believe it, but that's okay. And we have maybe 5,000 people on social media telling us that we live on a ball. I think 80% of them plus are paid because Space Force gets $25 billion a year, it only costs about $500 million, a small fraction of that, to fund cyber misinformation for your ball. It only takes about 500 million out of the 50 billion that NASA and Space Force gets, which is $136 million a day. $136 million a day, while 9 million people starve to death every single year in the world, while over 800 million people have hunger issues every single day, while 880,000 people in the UK and the USA alone, that's only 5% of the world's population, are homeless. And we lie to children in school that we're going into outer space, that the picture of Neil Armstrong in 1969 was actually him. We lie to people. We spend $136 million per day. 9 million people starve to death. Over 800 are hungry, homeless. We lie to children, and we believe we've been to the moon. People, we should be ashamed of ourselves. Outer space. Nietzsche said, we have killed God. And every time that we go into outer space, we kill God further. We should be ashamed of ourselves, but we are not. Matthew and I talked about this 2 weeks ago. There's not one passage in the Bible that says we live on a ball. Not one passage in the Bible that we live on a ball, but Matthew believes it anyway. It's okay. Belief system is great. Belief is the enemy of knowing. I know we don't live on a ball. Thanks.
Thank you. Yeah. So let me tell you where I agree with you. First of all, covering a lie with a lie, if you lie, you have to cover more and more lies. I think that's true. I mean, wasn't it Mark Twain that said, "I never lie because then you have to remember too much." And so, also, I would say lying to children is bad. I'm against lying to children, obviously. So, from my perspective, teaching children about the globe is not a lie; it's teaching them about the truth. But the bigger picture of lying to children, I agree with you there. Same thing with it's sad that there are people who die of hunger and die of starvation. All that type of stuff is bad, and those are interesting questions about how we allocate resources. And so that is something worth talking about. Like, how do we make it so that we can spend more money to help poor people? I would say, we probably spend more on cosmetics per year than it would take to feed all of the hungry people in this country. Yet people still buy cosmetics. So, those are interesting questions. That doesn't affect the truth or falsehood of the particular claim that I'm talking about. That's more a question of how things work. How we should be spending money. And then finally, I would say I agree. I don't want to be living in a cartoon world, in a fairy tale world. That's not what I'm about. Of course, I don't think the globe is a fairy tale or is a cartoon world. I think it's actually true. Okay, so to specifically address a couple things you mentioned, you listed a bunch of different places where you would expect using an Earth curve calculator with no refraction to not be able to see certain distances. You mentioned the Benton Harbor and Chicago thing, and the across the Grand Canyon. And I would say that each and every one of the examples you brought up, if you look at it carefully, there is a reasonable explanation that makes sense on the globe model. It would take time to look at each one by one, but just to give a quick overview. So first of all, the Grand Canyon thing, I'm not sure that really addresses your point, because you're not standing at sea level, and the North Rim is quite a bit higher elevation than the South Rim. And anyway, if you're saying there's nothing blocking the way, well, it's because there's a big Grand Canyon in the middle. So the Earth, the Earth isn't there. The point is, if there were a flat plane between the south rim and north rim, the question would be, would the bulge in between hide it? And so that's a separate question. As far as FE core looking over water and looking over Benton Harbor and that kind of thing, just to be clear about our differences, you're suggesting that should not be possible on the globe model, and I would agree with you that shouldn't be possible without refraction. However, especially over humid water and different atmospheric conditions, I think the path. So you said light doesn't bend, but I'm saying something slightly different. I say the path of light does bend. So you said it changes direction is not bending, and that's true. Changing direction is the path is bending. So if it changes direction, and just to be clear about what we're talking about, the difference in opinion is that over the course of 1 mile, for the light to bend 1 foot, even more than 8 inches. So if the light bends 1 foot, it's deflecting 0.0109 degrees. So that's the difference we're talking about. And it's appropriate to use degrees because we're talking about the difference in angular visual angular size, and 0.01 degrees versus 0.00 degrees to me is a small number. And I think that it's reasonable to think that in the humid, turbulent air right over water, that you can have effects that sometimes show Chicago from Benton Harbor. Not always. I mean, it depends on the atmospheric conditions, and that's a rare thing. And that's why that one meteorologist commented on it. He's like, wow, this is hardly ever visible, but today it is. Look, the weather conditions are just right. So I would say that those are reasons why I think that the globe model does indeed account for those examples you brought up. Now to look a little bit more in depth about the examples that I was talking about earlier, let me just bring up one or two things in relation to that. Since you expounded on some of your opening things, I'll do the same thing. If you're looking at a if you're watching the sun set over an ocean, I've used this example a couple times before. Imagine that the sun is halfway set. In other words, you could see the top half of the solar disk, but not the bottom. So the question is, why can you see the top and not the bottom? There's more air between you and the top of the sun than there is between you and the bottom of the sun on the flat Earth model. And so it doesn't make sense to me that it would just be the atmosphere, that it would just be some kind of atmospheric effects that would hide the bottom half, but not the top half. It's not perspective. Perspective makes things smaller and dimmer and appear farther away. Perspective cannot hide things from the bottom up. And so here we clearly see the sun from the bottom. The bottom is obscured. And I think the simple answer is that the bottom is obscured. It looks like it's obscured because it is. There's water between my eyes and the bottom of the sun. And historically, sunsets has actually been one of the chief reasons why people think that the sun goes below the earth. Now, thousands of years ago, they said the earth was flat and the sun goes beneath the earth. Now we know that the sun is going beneath the earth, but the earth cannot be flat because at the same moment it's going below the earth, from my perspective, it's still high in the sky out in Hawaii and Japan. And so that's why I think that the globe model describes that picture of the sun halfway through better than the stationary topographical plane model. Same thing for seasons. There is a perfectly reasonable, understandable explanation about how seasons work in the northern hemisphere and southern hemisphere, or if you want to say north of the equator and south of the equator, if you prefer those terms. For example, Sydney and LA are about the same latitude, north and south, and have very similar seasons and weather and sunrises and sunsets, except just reversed. 6 months off from Sydney compared to LA, and same thing north and south, northwest and southwest compared to where the suns rise and set. And so I think that symmetry is well explained by the globe model, and I'm unaware of any similar explanation that works well on the flat model. I mean, same thing with this idea that from two different places on the equinox, you can see the sun rise exactly in the east. The last thing I mentioned was this idea that the full moon appears the same size as it's rising. And if the moon is a physical object, and if the moon obeys the law of perspective, then we would expect that if it were coming at us as it's rising over a flat plane, that its distance would be decreasing quite a bit, and we should see it bigger as it's rising and then get smaller as it's setting. And I haven't observed that, and I'm unaware of anybody observing that the moon gets smaller as it's setting. Again, this is another example where I think the globe Earth model has a reasonable and good explanation for that, namely that the distance to the moon throughout the full moon, throughout the night, changes less than 1%. So the size changes less than 1%. And so these three examples that I offered as evidences, I wouldn't call them proofs. I would just say, hey, here's some clear observations that everybody can see. Now let's look at the two different ideas. The stationary topographical plane, what explanations does it have for these phenomenon? And the globe model, which explanations does it have? And to me, it seems like the explanations that the globe model have are more reasonable and explain it well and predict those ideas well. And the flat Earth model does not. And so therefore, that's why I generally favor the globe model over the flat Earth model, because in these three examples and many others, the explanations are better.
We'll do a little back and forth the rest of it.
Okay, yes. So that concludes our formal back and forth.
Yeah.
And I'm happy to chat about any specific thing that you.
Yeah.
I'm going to turn off my stream again.
I like to address your three items. I think you were talking about, if I remember right, my friend, sunsets, seasons, and the moon.
Right.
In general chat text in Earth Awakenings, general chat text, which I think is a little bit further down, I put a number of things in there. I'm going to deal with the moon first, and then we'll get to the other two things. I have 6 videos, 4 of them that I took myself in general chat text, 6 videos. Shane was nice enough, great guy, to put together 4 of them into a BitChute situation. The other 2 are from November 1st and November 3rd of this year, where it shows clearly that the illuminated part of the moon is not being, the lit part of the moon is not being illuminated by the sun. You'll see in all 6 of those instances that it is not being done. One is a minute 39 long, the other is a minute 55 long, and then there's 4 of them in that BitChute piece. The moon is not being, the illuminated part of the moon is not being lit by the sun. It shows it clearly. It's a video. It is not a still picture. Matthew has yet to provide any even still picture of the moon staying the same size as it goes across the sky. I've heard him say it a number of times that the moon has not changed size. He says it. I want to know what his, what his expert observation, says about that, either than just his words. He says that. I show you videos, 6 videos of the moon facing not directly at the sun. Maybe the moon is illuminated at 1:32, 2:30, 3 o'clock, and the sun is moving away at maybe 5:30. 6 videos, folks. 6 videos. No pictures, no images, no, the moon stays the same size all the way across. So you can go with Matthew going, well, the moon stays the same size. Okay. or you can go with 6 videos that I showed you. I'll leave it up to you. If that kind of takes care of the moon discussion, I'll throw it over to Matthew, and
Sure.
then when we come back, we'll talk about seasons.
Yeah,
And
I'll quickly address what your concerns with that. First of all, I commend you for doing your own research, getting out there and making videos, and I think that everybody should do that kind of thing. It's just better to kind of like do your own observations than to just believe what you see, what I say or what Jim says, right? That said, I do think that your videos are genuine and accurate. I will say this: what you're experiencing is something different than what I'm talking about. What you're experiencing is something called the moon terminator illusion, and it's the fact that when you make two-dimensional images of the three-dimensional space, it's sometimes hard to understand how straight lines work. Straight lines kind of arc across the sky, and so understanding three-dimensional geometry, I think, provides an adequate explanation for your videos there. Specifically, I was talking about the full moon where there is no terminator, so that doesn't directly correlate to what I was saying. And as far as images showing the moon is the same size, I'm sharing one right now on my live stream on my screen share. That's one example. And then I've done this myself. I've gone out in a full moon and taken during the night of a full moon and taken images of the moon throughout the night from moonrise through midnight through moonset. And so I personally have observed from my own observations that the moon is the same angular size all night long during the full moon. I understand if you don't believe me, I'm just reporting my own observations. So I would say check it out for yourself. Okay,
yeah,
go ahead.
I think the reason, and we brought this up a couple weeks ago, I think the reason that I talk about these things in this 6 videos is that we've been taught. Nietzsche said that we killed God, and seemed to be pretty proud about it, and that we kill God every time we go above the firmament, which is talked about quite often in the Bible, which we talked about a couple weeks ago. That video, that 2-hour video of exchange is actually in the general chat section if you scroll down far enough. So Genesis 1:16-17, which I know a lot of people aren't brought up with, because in 1962, the Supreme Court with Engel versus Vitale basically told kids that in a group session they cannot pray in school. They can pray by themselves, but they can't pray in a group session anymore. And in the same year, 1962, we had in Haight-Ashbury, Haight, in San Francisco, we had the beginning of sex, drugs, and rock and roll. And you know, a lot of us aren't old enough to remember. I am, sadly, about Woodstock in 1969, which was basically a sex, drugs, and rock and roll get together. So we've killed God. We've killed God. And outer space is the greatest way to kill God, because nowhere in the Bible, which Matthew, I generally believe, loves, nowhere in the Bible does it say that we live on a ball. It talks about living on fixed, stationary foundations. Foundations are often, many times, mentioned in the Bible. There is no foundation on a ball. There is a core. When it talks about the ends of the earth, there are no ends on a ball. So the Bible is quite clear, and Matthew says he loves the Bible. He believes the Bible, but he has said that before. This is what we talked about a couple weeks ago. God is not on this globe, if this was a globe. The globe is a satanic invention by the devil to take us away from God's creation. We have thrown the Bible out. Like I said, Nietzsche said we have killed God. We kill God every time we go into outer space that doesn't exist. We kill him every time. You've seen the memes that said, you know, God is not up here, an astronaut holding it. God's not up there. He doesn't say that we're up there. God made
Can I
us.
answer?
God made a special place for us. Now, whether you believe in an actual dome or a tent, whatever you believe, that's fine. But God, outer space, planets, solar systems are nowhere in the Bible. Thanks, Matthew.
Yeah, so let me just, I mentioned this briefly in my opening, that I do think that, so first of all, I am a theist. I believe God created the universe and designed life and all that type of stuff. And I do think scientists are overstepping their bounds when they say things like science shows us that God doesn't exist. I'm like, no, that's a statement of metaphysics, not a statement of science. And scientists are free to engage in metaphysical statements. They just need to recognize that they're doing philosophy, not science. Uh, so in that sense, I agree that sometimes scientists overstep their bounds. However, from my perspective, I actually think that studying science and understanding the world actually brings glory and honor to God, and understanding the way that He created the universe is something that we should be doing and trying to find out. And I think the evidence clearly shows, and most theists would agree with me, that's not an appeal to authority. I'm just reporting that the vast majority of theists and scientists who believe in God agree that the clear evidence shows that God created the universe, and designed things such that the earth is a sphere. And that's not, so it's not saying being anti-God to say that the earth is a sphere, even though that there are some atheists who say that the earth is a sphere. But we can move on. We
Go
don't,
ahead.
I don't mean to like bring up biblical cosmology that much. I'd be happy to go through those 3 points you originally
Yeah,
started. You said
sure,
with the moon, and then what you want to
sure,
talk about, seasons or sunsets?
sure. The last point, I'll move on. Genesis 1:16-17 says, God placed two great lights in the sky, not one to give light upon the other, placed two great lights in the sky and the stars. I have an owner's manual in my car. It doesn't tell me my car can fly. I wish it could, but it doesn't fly. So the Bible doesn't say that we are spinning at 1,039 miles per hour, falling away from the sun, which gives us sunsets on the globe, going around the sun at 66,600 miles per hour, 666, in an elliptical orbit, going around the solar system at 450,000 miles per hour, going around an ever expanding universe at 1.3 million miles per hour, while Polaris, the North Star, has always remained above the North Pole, and we go counterclockwise around Polaris, and the constellations have maintained their distance within each other and have not gotten brighter or dimmer. So my owner's manual in my car tells me what I can do. The Bible tells us, God's word, what we can do, and we're not spinning, rotating, and all those things. And we're not a ball because it would say that. It's amazing how people appeal to authority, consensus, propaganda, emotion, popularity, majority, regurgitation, a piece of paper, and a diploma, but they never appeal to the ability to think for themselves ever. Go ahead, Matthew, and after you, then I'll start going to the seasons and the sunset. And you're on mute, Matthew.
Okay, now can you hear me? Sorry
Yeah,
about that.
sure can.
I
Thanks.
It was probably my fault. I thought it went somewhere. Okay, so you brought up some more. You so you continued bringing up some more biblical cosmology stuff. So
I,
maybe
I'm
I'll
done.
just leave. Yeah,
I'm done
I'll
for
just
now.
yeah. So I'll just leave it at that. So I'm happy for you to continue on the non-cosmology stuff. I mean the non-biblical cosmology stuff.
Hey, in the general chat text, there's two examples of the sun moving away on a stationary topographical plane. One is a laser or some sort of green light on a table, and the other is somebody walking on a football field. Now, I know some globe enthusiasts, like to say that football fields drain in a certain way. Yes, they do. Some of the newer ones and some of the older ones drain from the center of the football field down to the sidelines. But when they're going north-south from the end zone to the end zone, in the middle part of the field where field goals are kicked, it is straight. It is straight. So when that gentleman in that 3-minute and 9-second video is walking away, and the bottom part of him is being lost, and in that green light on the kitchen table, the bottom light is being lost. That shows that the bottom on a sunset on a stationary topographical plane will also disappear bottom up. Now, I have shown videos of the moon. I have shown videos of a sunset, 2 cases where a sunset would lose going bottom up on a stationary topographical plane. That's 2 out of 3. I'm going to get to seasons here in a little bit. And then I'm going to get to Matthew and my favorite thing to talk about in the last 7 months, the Trans-Australian Highway in Australia. And we'll have a nice talk about that. But anyway, Matthew, it's yours. I'll come back and do seasons.
Yes. So I didn't have a chance to watch those videos just now, but I think I'm familiar with the one with the guy walking across the football field. And as the person is disappearing from bottom up as he walks farther away, I would say the same thing is happening. The ground is blocking him. There's a physical obstruction between the camera and the bottom of his feet, or some optical effects. It depends on the specifics of that, and we'd have to look at that more in more detail to look at it. Same thing with this, with
Matthew,
the little paper sunset moving away.
It's not curving away, Matthew. It's not curving over a ball.
I'm saying that if you can't see something, there's only 2 reasons why you can't see something. One is that it's too far away and becomes too small, and 2 is that it is physically obstructed and you can't see it that way. I guess the third one would be if there's enough atmosphere in between your eye and that thing that would sort of block it out. And I would say the same thing is true in those 2 cases. Now, as far as you brought up again the moon observations that you did, and again, I commend you for doing your own research. But for anyone interested in the explanation of why that's happening, just look up a moon terminator illusion, and there are decent explanations online about how that works. Okay, go ahead.
Hey, Matthew, what time of the year is the northern hemisphere closest to the sun?
Well, the northern and southern hemisphere are closest to the sun, I think in January.
Okay, that's good. I'm glad.
I think the farthest is and in the elliptical orbit currently, the farthest is when the Earth is farthest in July.
Yes, it is. You done well. I commend you on that. A lot of people can't answer that. You have we'll get to the seasons here, and then we'll go somewhere else. Obviously, on a stationary topographical plane, you still have 23.4 degrees north for Cancer. You still have 23.4 degrees south for Capricorn. They move back and forth, north-south, during the year. And you get your seasons. So you can have seasons, and you can have times.
Is the Tropic of Cancer smaller? Like, is it a smaller circle?
The Tropic of Cancer will be a smaller circle than the Tropic of Capricorn. If you look at how things, if you notice how things work, they work in a figure 8, and the bottom part of the figure 8 is much wider than the top part of the figure 8. So that explains why one is further around, or the great circle around the Tropic of Capricorn, than around the Tropic of Cancer, both at 23.4 degrees. So if you look at how they work during the year, on a figure 8, you have a much bigger part of the figure eight on the bottom than you do on the top. That's how it works. Now, the globe community, if there is a community, they don't like that because they like their, Matthew, for some reason, you like your tilted, wobbling, spinning ball where we're taught that a person,
I would call it an eccentric
on top
orbit
of
rather than tilted and wobbling.
a person on top of the ball is standing straight upright. A person on the side of the ball is still standing upright, and the person at the bottom of the ball is still standing upright because gravity pulls everything towards the center of the ball. But the only
Right, they have
reason
different perspectives.
the only reason gravity exists is to explain why people and water don't fall off the sides and the bottom of a spinning ball. If we have time, I would love to get into gravity with you, as well as why light changes direction in air. Hopefully we have time. If we don't, maybe we can do it again sometime. But there's a lot to
Okay.
be talked about with gravity on this situation right here, and I'd be happy to replace your cartoon fairy tale gravity with something that actually makes sense.
Okay, so just a couple of comments. I think the Tropic of Cancer and Tropic of Capricorn are good examples of yet another example where the explanation on the globe model works better than on the flat model, because both on both solstices, the day is about 24 hours long. And so the sun goes around the smaller circle in 24 hours and also goes around the larger circle in 24 hours. Yet people who are at the subsolar point, in both places, they still see the sun move exactly 15 degrees per hour. And so it's irrational to put all three of those things together. It geometrically doesn't work. The sun cannot be moving 24 hours at the same speed in a smaller circle and 24 hours in a larger circle and be going the same speed. Either the speed is different and it's wrong, or the measurements are wrong, or the day is wrong. But everybody knows that the day is 24 hours. So my answer would be that the idea of the sun going in a smaller circle sometimes of the year and a larger circle other times of the year is clearly false because of observed angular speed from everywhere on Earth.
Do you believe, Matthew, that it's sensible to look to the celestial to prove the terrestrial?
I think it's all evidence is fair game when you're trying to figure out how the cosmos works. Yes, so looking up at the sky to determine how the seasons work. The seasons are clearly influenced by the sun, and so of course, looking at the sun and figuring out its movements is going to help us determine the seasons. And the point of, I see what you're saying. You're saying, why should we look at the sky to determine the shape of the ground? And the answer is because there are two options in contention here: a description of seasons based on a curved ground and a description of seasons based on a flat ground. And that's what we're talking about.
Instead of looking at seasons, looking at the moon, and looking up a bottom-up sunrise, which is celestial, we're in the terrestrial, for people who want to know, which means on the Earth. Do you ever experience 8 inches per mile squared on a radius of a ball of 3,959 miles? Where have you, Matthew, ever experienced with your eyes, with observations and experiments and experience, have you ever experienced 8 inches per mile squared?
That's a good question. The broader answer to your question is that I do not think that personal experience is the final arbiter of truth. Just because I haven't personally experienced something doesn't mean that it's false. And in general, I would say that you're right, that directly measuring the curvature of the Earth by a direct measurement, like putting some steel beam out or something like that, is incredibly difficult, or maybe even false, or I mean, not false, impossible. So instead, the 8 inches per mile and the number 3959 for the radius and all those kinds of things are not directly measured. They are instead calculated based on other ideas. And so also, I would say that just like I have never directly experienced 8 inches per mile squared with a direct measurement, I have also never in my entire life experienced with my own senses Wi-Fi signals coming out of my telephone. However, I believe that they exist. So sometimes I believe things that I do not directly experience.
Michelle Fowler and Bill Nye will disagree with you because in their 10-minute video, with Neil deGrasse Tyson, they say boats go over the horizon. And the reason we can experience Earth curvature is all we have to do is go to the beach and look at boats go over the horizon. Do you disagree with Michelle Fowler and Bill Nye?
I think that those are good examples. I think that watching the sunset or the moonset over the horizon is even a better example. It's even more clear. That's why I brought up that instead of boats.
But you disagree with Michelle Fowler, NASA, and Bill Nye that you can visibly see boats go over the horizon.
I think it's easier if you have a telescope, but you can see boats go over the horizons, disappearing bottom up.
And so can you prove, obviously, your horizon is what, apparent or physical?
If you're looking at the horizon, it's apparent. I mean, if you're modeling it in a mathematical model, then there's a geometric mathematical horizon.
If you said apparent, Matthew, welcome to Flat Earth, Matthew. You know, apparent is what the stationary topographical plane the flat earthers believe. Because on your globe, Matthew, your horizon is geometric and physical, and you can see it. But on the flat earth, I hate to use the word flat earth, but forgive me, it is apparent. So when you said apparent, welcome to Flat Earth, Matthew. And you know what? The water's just nice and warm over on this side as well.
So I reject the sophistry of saying welcome to Flat Earth as a legitimate argument. But I mean, it is entertaining.
No,
so I get what
I'm happy. I am happy you're joining us.
So from the globe perspective, the geometric horizon exists in a theoretical model and in mathematical equations and stuff. However, when you're looking at it, we're actually looking at the apparent horizon, and generally they're about the same. However, if there's significant refraction, then the apparent horizon might be different than the geometric horizon. And in general, I say that like these tiny differences, remember we're talking about differences of 0.03 degrees with that whole black swan thing. And so oh, I don't have that picture here. Yeah, that one. And so I don't think that squinting at the horizon is super helpful in most of these cases.
I don't think squinting at all is good, but anyway.
Right.
It's to squint to prove a point, I think is not really a good point. But anyway, so the only place, Matthew, that I've ever seen bendy light is at the grocery store. You can go down there and get a 6-pack or a 12-pack of bendy light. They sell it in cans, and you can get it alcohol or alcohol free, because bendy light does not exist.
You ever seen heat waves on the top of a hot car in the summer?
You know what's fascinating is
heat waves are bendy light.
No, that's not bendy light, Matthew.
It certainly is.
No,
what
Matthew.
Is it?
Matthew, that is heat coming off the car that the light goes through. And when light goes through molecules that are heated, they will go through and they will change direction. They will not bend. They will change direction and remain in a straight line. If you go to where I put those things in the general chat text, and you look at, let's see here, I put that in there. It's that little area where they're looking at the shoreline, and it's going up and down like this. during the course of the day.
The skunk bait. I love that image because it shows how unreliable looking at the horizon is.
Exactly. But nothing is bending. If it was bending, we couldn't see anything.
Would you be happier if
what
instead
else?
of saying bendy light, I said bendy light paths? So you're saying that
No,
light changes
no,
direction, so
no,
therefore the path
no,
changes. The path is
no,
bent.
no.
No? Okay.
It's see Matthew, you're trying to prove your ball. You're trying to
No, I'm
prove your
trying.
plan.
I'm just conflating the idea of bending, changing direction. I think is sort of synonymous with bending, but it sounds like you don't like that.
Well,
You like
here's
you say it's changing direction, but you're not happy with me calling that bending.
it's okay. It's okay. Here's
Okay.
what here's what's fascinating. Here's what's fascinating is that if we take away bendy light and we take away your gravity, which I'll be happy to do if we have enough time, you have nothing.
That's correct.
You have a ball that's a cartoon or a fairy tale.
That's correct. If you
all.
deny the reality of gravity and refraction, then we have just a fairy tale.
You got a fairy tale, and I feel really bad leaving you with a fairy tale.
I don't think you can take those away. That's why I'm not troubled by that.
Here's a perfect example. Here's a perfect example how the globe advocates think. And I'm not going to straw man you, but this this is the perfect example how Chicago skyline, geometric horizon 6.47 miles away, 30 feet observation height, 62 miles. You can even see the sun moving away behind Chicago at certain times of the year. Okay, to you good folks, what you're looking at there, what Tom Coombs was looking at, saying it was bent over the ball, but a mirage brought it all up so we could see it just perfect from 56 miles away, Mirror State Park. That you aren't looking at the Chicago skyline, Matthew. You're looking at a holographic projection of the Chicago skyline from behind the alleged and assumed edge of the Earth curve based on NASA, mainstream science, land surveyors approved and used Earth curve calculator of a cartoon. That's what you are telling us. In reality, you're telling us that we can see this geometric horizon, your Earth curve calculator, 8 inches per mile squared. You should be a geometric horizon at 6.47 miles. I can see Chicago at 62 miles away, and I can see during certain times of the year the sun moving way behind it. But you're telling me, because Tom Coombs at ABC 57 said it was a mirage, and he had to come up with something, because if he didn't, he couldn't get to Chicago or Detroit or Columbus and get out of South Bend, Indiana, because if you take Notre Dame out of South Bend, Indiana, the unemployment rate goes to 30% in South Bend, Indiana. I lived in Indiana. I know what South Bend is. South Bend is dependent on Purdue is dependent on, Lafayette is dependent on Purdue. Bloomington is dependent on University of Indiana. Muncie is dependent on Ball State. So you have South Bend is dependent on Notre Dame. So Tom Coombs is going to say that because he wants to get his family out of probably the lowest market in Indiana, maybe the Midwest. Because if you take Notre Dame out of South Bend, it's 30% unemployment. So
okay.
he's appealing to his checkbook to money. Thanks.
I see. So you're speculating on the psychology of a particular weatherman about his motives for saying something on TV and his financial situation. And I'll refrain from such similar speculation.
After communicating with him and knowing what the situation is in that part of the country, absolutely.
So as far as if the path of light bends, um, I'm happy to say that you're looking at the thing. These are devices right here that bend light, and so I would say that when you're looking through devices like this, you're still looking at the thing, and so I think it's okay to say that you're still seeing Chicago, even if the path of light was bent slightly from Chicago to Benton Harbor or wherever that was. Remember, I'll remind the audience that the difference we're talking about is that for every mile, the light, if it bends merely 0.0109 degrees, that's sufficient to explain the Benton Harbor observation. And I think that, looking at humid air, if you've ever seen turbulence on top of a car at summer or heat waves in a hot road, I think the same kind of thing is happening. Basically, just the path of light is bending slightly. Only 0.01 is all we need over Lake Michigan to explain that Chicago image.
I know a lot of the globe advocates, and I consider you a globe advocate.
I advocate people. I think everybody should believe in the globe. I think that nobody should believe.
And I know, Matthew, you told me when we first met in March and April last year that the more education you have, the more chance you had to be a globe person.
In particular, if you took physics in high school,
I remember our conversation, Matthew. So so the more let me get the audience up to date. Matthew and I started talking on 24-hour Discord last March, and he said the more education you have, the more likely you are to believe in a ball.
Yeah, it's a correlation, not necessarily a causation.
Yeah. And so if you aren't, therefore, if you aren't educated with a diploma, piece of paper, regurgitation, all those things, you are more likely to believe in a flat earth. But the more regurgitation you have, the more diplomas you have, the more appeal to a piece of paper you have, appeal to regurgitation, appeal to, this, and this, the more chance you have to live on a ball that you have never experienced in your life. You've never experienced 8 inches per mile squared. You've never seen spin. You've seen motion. You've never seen gravity. You definitely can't explain the bending and warping of space-time that Picari came up with, that Einstein stole. And you definitely don't understand in 1915 when somebody saw a star through an eclipse. You can't have that. So you throw Newton to the curb with his mass attracts mass going towards the center of a ball, and you replace it because you got to explain away that star through an eclipse in 1915. So Eddington decides to explain it away, and Picari comes up with the bending warping of space-time, which Einstein stole because Einstein married his first cousin, wanted to have a relationship with the first cousin's underage daughter, who was an ethnic supremacist, and you put him on such pedestal that, he's a puppet, but you love him anyway because he gave you relativity. He gave you, which nobody
certain
can.
Scientists' personal life is not an argument.
What is the bending and warping of space-time? You don't have to answer now, but give me an answer before we're done.
Okay, so Einstein's personal life is irrelevant to this conversation. I would submit, and then I brought up you reminded the audience that I had brought up the correlation between education and belief in flat Earth, and so I agree that would be merely an appeal to authority, and so that's not proof in and of itself. However, I still think there is a correlation, and presumably you do too. I'm not sure. As far as seeing stars through the dark part of the moon or an eclipse, I don't think that's possible, and I think that any reports of such are false or can be explained by some other phenomenon. So
that's how we came up with that's how Eddington came up with the bending and warping of space-time, because in 1915 we saw a star through an eclipse. We can't have that, so we decided to make this,
not through an eclipse.
Eddington decided to go ahead.
So I think you're referring to the confirmation of Einstein's theories during an eclipse where a star appears slightly in a different spot than you would expect if it weren't right next to the sun, not through the middle of an eclipse. But
Do you deny the 1915 eclipse where they saw a star coming through an eclipse when they shouldn't have, and they had to throw Newton to the curb and come up with the bending and warping of space-time to explain why you could see a star through an eclipse?
I deny that they saw a star in the middle of the moon in the eclipse. I think you're mixing up the story a bit. What they did do is an experiment to determine if the location of the star was slightly bent due to gravitational effects. We would have to look into more detail about what you think you're saying.
Yeah. So we talked. Thank you, Matthew. Thank you for your honesty. We talked about Eddington. We talked about the bending and warping of space-time. Before we're done, if you could tell me what the bending and warping of space-time is. Then we come back to
I'll answer that right now.
Morley.
I don't know. I'm not an expert in that type of cosmology.
Hey, that's fair. Because nobody does, Matthew. So don't feel like you don't know because
you could prove that the Earth
knows.
is a globe using Newtonian mechanics. You don't have to use any of the modern stuff.
Yeah, gravity.
Newton believed the Earth was a sphere.
And Newton, you mentioned 2 weeks ago that Newton was a Christian or maybe loved God.
He was a strong Christian. He wrote all kinds of theology stuff.
No. But that
have
was
you
2
read
weeks
any of his stuff?
Yes, I've read his stuff now.
You've read his theology stuff.
Since you said that, and it's just absolutely fascinating. But that may be a discussion for another day.
Yeah. So, that's bordering on biblical cosmology.
That gets back into biblical cosmology, exactly. And then I want to touch on Michelson-Morley, 1887, which I find fascinating because Google has thrown that experiment under the bus. Because before Michelson-Morley, it was assumed that the Earth was traveling 30 kilometers a second throughout this elliptical orbit, and which is about 18 3/4 miles per second. So 30 kilometers, 18.75 miles, and they did it for the whole year. They looked at it for the whole year, and they found out, and even Michelson himself says that the results were nil. And so, in other words, it was such a precise test done over the course of a year that they couldn't even detect 2 kilometers per mile. I mean per second, 2 kilometers per second. And so Einstein had to, if he didn't steal Picari's stuff, Einstein had to go, hey, I have come to the belief that the motion of the Earth cannot be detected by any optical experiment. And I have a lot of them here that deal with philosophy, that deal with motion of the Earth, that it cannot be detected. Motion of the Earth cannot be detected from the Earth. Matthew, I can read them, or we can just talk about it now.
Okay, let me respond in general to that. We cannot
detect motion of the Earth from the Earth. Why do we know it exists?
Through other methods. So you're correct that Michelson-Morley, using a certain technique, failed to prove that the Earth is moving with that technique. Now, failure to use a certain technique to discover something doesn't mean that thing is false. Similarly, I have failed through optical visual means to determine that this is emitting Wi-Fi signals. That because I've failed to do that by looking at it does not mean that there are not Wi-Fi signals. It's the same kind of thing. Let me explain why it's relevant.
Matthew,
can I explain why it's relevant? No, I'm not diverting. I'm using an example. Using one kind of technique to try and show something and failing at that one technique, that does not automatically mean that you've proven the opposite. So failing to prove something is not proving the failure.
I don't want to bore everybody, but
you have lots of quotes of people saying this didn't work. Sure.
It's amazing that we haven't seen or can define gravity, which is now the bending and warping of space-time. That's relativity. We can't see spin. We can't see motion. We can't see any of those things, but we believe them anyway. So why do we believe them, Matthew?
We could define gravity as what we experience. I mean, you could say that it's the 9.8 meters per second that we experience. What if I define it that way? I mean, understanding why gravity happens is a whole different question than understanding what it does. We have pretty clear ideas of what it does, even if you don't know why it does.
No, nobody says that things don't go boom boom 9.81 meters per second as an agreed average. But we dispute the cause. We dispute gravity.
I'm happy. Yeah, you can dispute the cause all you want. That's fine.
Now I got like 3 different directions I can go here. I got 3 different directions I can go. Go?
Which 3? Which ones are you thinking about?
I want to go philosophy.
Okay. I love philosophy. Yeah, go for it.
Okay. I want to go, because nobody's seen motion, nobody's seen spin, nobody can explain what the bending and warping of space-time is, relativity, which Einstein stole. There's a gentleman by the name of George Wald, W-A-L-D. He says that leads us scientifically to only one possible conclusion, that life arose as a supernatural creative act of God. I will not accept that philosophically because I do not want to believe in God. Therefore, I choose to believe in that which I know is scientifically impossible. Spontaneous generation arising to evolution. It's a philosophy.
I agree with that statement. He's engaging in scientism and incorrectly conflating the philosophy of science with science. He's incorrectly conflating those two ideas. So go ahead.
Johannes Kepler, one of the 5 great people that took us to heliocentrism, which I call Satan centrism. That's a discussion for another day.
Oh, I would flip it and say the other way around, but go ahead.
Kepler said, I demonstrate by means of philosophy that the earth is round and it is habited on all sides, that it is significantly small and is born through the stars. It is a philosophy. Here is Edwin Hubble. Guys love Hubble. Such a condition would imply that we occupy a unique position in the universe, in a sense, to the ancient conception of a central Earth. This hypothesis cannot be disproved, but it is unwelcome and would only be accepted as a last resort in order to save the phenomena. Therefore, we disregard this possibility. The unwelcome position of a favored location must be avoided at all costs. Such a favored position is intolerable. Therefore, in order to restore homogeneity and to escape the horror of a unique position, us being important, must be compensated by special curvature. There seems to be no other escape. One last one, and then the floor is yours, and then we go to any direction you want to go. Thank you for listening. As astrophysicist Singal, S-I-N-G-A-L, the apparent alignment in the cosmic microwave background is one particular direction through space is called evil. It's evil to believe like I do and like others do, because it undermines our ideas about the standard cosmological model. The Copernican principle seems to be in jeopardy. Matthew, we can't see motion, we can't see spin, we can't experience orbit. We've never seen 8 inches per mile squared. We haven't done these things, but we believe it anyway. Quick thing on the biblical part. Doesn't say in the Bible that we live on a ball, but for some reason 85-90% of people say we live in a ball, and this is the reason why. Ego, pride, reputation, indoctrination, Stockholm syndrome, cognitive dissonance, and confirmation bias. Because our experience tells us we live on a stationary topographical plane, but our indoctrination and our ego and our cognitive dissonance says that we do not. And you know what? We want to be accepted at a Christmas party with our family in a few weeks and not be ridiculed because they think we live on a flat earth. But if we say we believe on a ball, even though we never experienced the ball, we're accepted at Christmas dinner.
Yeah, you bring up an interesting thing, the sociological consequences of having non-standard belief systems. And I imagine and have sympathy for all of you who have family members who disagree with you and argue with you about this type of thing. In general, I would hope that family members would be more charitable and kind to divergent views, but that's a separate thing. So you are correct that these things about scientists not liking the idea of being at the center of creation, those are actually metaphysical statements. Those are statements of philosophy. And I would actually disagree with them. I would say that I actually don't have a problem with the idea that maybe we are at the center. Maybe we're not, maybe we are. Adam and Eve were plunked down in the Garden of Eden, but they weren't at the center of the earth. Or maybe they were. Maybe you could say that maybe that was sort of the center of God's good creation or something like that. The Bible does not say that the earth is a globe. The Bible does not say that electromagnetism exists. You are correct. There are many things the Bible does not mention. So I'm okay with believing in things that the Bible doesn't mention.
Hey, you know what's fascinating is that when I have this, water is level in my little bottle, and then when I take a sup and close it back up, it's still level. And we're told we live on a ball with gravity, which nobody can explain. And
lots of people can explain it, not me.
71%. I love for you to do that if you could. 71% of supposedly our ball is made up of large bodies of water at rest. Don't curve. They're like this, Matthew. They're like this. They are level. But for some reason, we're told that they're curved at 8 inches per mile squared, even though nobody has ever seen it or experienced. Now, we're not talking about meniscus in a test tube, and we're not talking about beating on a windshield and a leaf that's outside that's just got a little bit of rain on it. We're talking about large bodies of water at rest, unmanipulated by weather, are like this, Matthew. See this? And when I take a drink, it's still like this. So why do you believe you live on a ball when 71% of something is flat and when it's at rest, but you believe it bends around a ball and you've never seen it bend around a ball?
Okay, so yeah, using the word level as a proof of something, I don't think that quite works. So none of us heliocentrists say that the surface of the sea, the surface of the Earth's ocean, form a perfectly straight line. None of us say that. So if the surface of the ocean formed a perfectly straight line in every direction, then you'd be right. It wouldn't make sense. How on earth could it be a ball? So just as a point of clarification, when we globers say the word level, what we mean is that it's roughly gravitationally equal potential lines, and that level is actually curved slightly. So the common sense definition of level is a perfectly straight line, but when we globers talk about sea level, we're not using that common sense definition of level. We're using something different. And in fact, maybe we should, for the purposes of this context of this discussion, we could use some other word instead of level. That's why I've been saying the phrase perfectly straight line. So in general, I think the difference is that flat earthers generally say that the surface of the ocean forms a perfectly straight line, and we globers say that the surface of the ocean does not follow a perfectly straight line. But you can't use the definition to prove something. So you're right about it. If it were a perfectly straight line, then it wouldn't work. That's true.
I like to use this phrase, and it's not my phrase. I borrowed it, like I borrowed basically everything. Like we all have borrowed things. I like to use what the globe enthusiasts use for level is not curved. I mean, level is curved, to explain their ball. I like to
Yeah, it's
use the
just a
phrase,
description of how we use words, right?
I like to use the phrase mental gymnastics that you use to explain water that is level, that is curved. You
I
use
would call it a
mental
careful
you,
explanation, not mental
you
gymnastics.
use mental gymnastics to explain your ball that you've never experienced with your eyes and your senses. You've never seen 8 inches per mile squared. You've never experienced spin or motion. You look to the celestial to prove you're terrestrial. You look up in the sky and go, "Hey, we live on a globe. Look at, hey, Matthew, look at the sky above. We live on a globe. Matthew, come down to Earth. Love your stationary topographical plane. You may lose some friends, but you're going to gain friends that you never knew you had because you decided a long time ago that you wanted to believe in something that goes against physics, because the second law of thermodynamics says you can't go up, 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 and up, and we're told it's uncontained against a vacuum of outer space that is 10 to the negative 17 torr, which we've never measured more than 10 to the negative 6 torr here on Earth. So we're told we go up, 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 and up. We will eventually get to the vacuum of outer space, which is 10 to the negative 17 torr, which is 11 zeros more than the 6. And then we're told that if we try to come back, like we were told in Apollo 13, the movie by Gary Sinise and Kevin Bacon and things like that, if we come back, then we have, Matthew, we have this much of a possibility to get back in. And if we come in too steep, we burn up, and we come in too shallow, we go out into outer space. Now, we can go up, 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 and just fine. But when we come back, we can't get back unless we go through something that's basically as thick as a piece of paper. That was told to us on CBS. Wally Schirra, I believe the guy's name, because I'm old enough to remember it. Black and white TV, and we have to get through that. You know what's the sad thing about that? Is I believed it. That's the sad thing. Is I actually believed that crap, and so it's amazing what indoctrination does to you. All yours, and then I want to go a different direction with your permission.
Sure. Yeah, I'm happy to go to a different direction. I'll just quickly respond to a couple things you said. I actually think that looking at the sky does give us valid information about the cosmology. Like if we're trying to figure out the shape of the universe and the description of how things are
Ball,
looking at
Matthew.
the sky.
We live on a ball by looking up there. I like it.
Right, exactly. Though that can give us, just like looking out the train window can give us information about whether the train is moving. Also, I would say that
Non sequitur, Matthew.
personal experience is not the only way of determining truth. And you mentioned the 10 to the negative 17 torr. Why not just call it 0? It's close enough to 0. And when you're doing pressure differentials, you're subtracting, not dividing. And so that's why you
11
might as well call
zeros,
it 0.
Matthew. 11 zeros,
Right.
Matthew.
If you subtract, then those 11 zeros are, don't matter in terms of precision. So, this ISS is 14 point something psi on the inside and 0 on the outside. So you do the subtraction and get the pressure differential. If you're subtracting 0 versus subtracting 10 to the negative 17, it's going to be like hardly any difference.
Did you say the ISS? Did you say the internet? Did you say the International Space Station, or did I hear that wrong?
Yes, the International Space Station. I brought up the idea that sometimes you guys say that because there's no way that the International Space Station could hold a pressure of 14.7 psi against a 10 to the negative 17 torr vacuum. And I'm saying that that's a misunderstanding of how pressure differential works.
And, Matthew, do you believe in the vacuum of outer space, 10 to the negative 17 torr, that a rocket can push off itself?
Close enough to 0. Yeah.
Did you believe that a rocket in the vacuum of outer space can push off itself and propel itself through outer space in the vacuum of outer space?
It's Rowing a boat, you're pushing off the water, but in a vacuum, a rocket does not push off air in order to propel itself.
Newton's third law of motion would disagree with you. Down here on
No,
Earth,
it's because of Newton's third law that it works.
Newton's third law of motion down here, where we live, says that if you have a boat, it's working against air in the water. If you have a submarine, it's working against the water. If somebody is jogging, they're working against a little bit of air, but basically the ground. If somebody's driving, they're working against the ground and a little bit of air. If you have an airplane is working against the air. But for some reason, so for every motion going forward, there's a motion, pushing it back. That's Newton's third law of motion. But for some reason, in air, Matthew, there's no air in outer space unless you believe there is now air between here and your moon of 238,000 miles away.
Yeah, this is an example of where physics education would be helpful. Let's say this is the rocket. Here's the propellant, and as they turn on the rocket engine, the propellant goes shooting out the back. And Newton's third law of equal and opposite reaction says that therefore the rocket will move forward. So when you turn on the rocket, it goes this way, and the center of gravity actually stays the same.
What's it pushing off of? Push off of something.
The center of gravity doesn't move.
When a rocket goes up, it's here on the Earth, it's pushing off of the air, and so when it gets into the vacuum of outer space, Matthew, what's it pushing off of in the vacuum of outer space?
I feel like you didn't even understand my illustration. Here's the rocket. Here's the propellant.
I don't live in a cartoon world, Matthew.
Me neither. Here's the rocket. Here's the propellant. You turn on the rocket.
I don't live in a fairy tale, Matthew.
Are you interested in hearing my explanation, or should we move on?
Please go ahead.
Here's the rocket. Here's the propellant. You turn on the rocket. The propellant goes shooting out the back at a high speed. In order for Newton's third law to apply, when that happens, the rocket moves forward, and the center of gravity is still right here in the middle. So the rocket moves forward because the propellant moves this way, and that's what propels the rocket itself, even though the center of gravity between the rocket and the propellant is stationary. So you're right.
In the vacuum of outer,
you're not
in the vacuum of outer space.
You understand what I mean by center of gravity?
In the vacuum of outer space, which can't be shown down here on Earth, but for some reason, because people want to believe in their atheist outer space monkey religion, it works in the vacuum of outer space.
I don't think atheism has anything to do with this.
I love it. Hey, Matthew, you kill God just a little bit more when you talk about outer space travel. And Nietzsche, if he could hear you, would say, "Good job, Matthew."
I'd see it a little bit differently. I'd say you grossly misrepresent God's glory and creation every time you say the earth is flat. If we were to ask Jesus Christ himself, who made the earth, what shape the earth is, he would say it's a globe. It's my opinion.
Would Jesus take the shot 4 times like you have because you were told?
No, he would not, because he is perfect. So wait, actually, I'm gonna retract that and say let's not talk about that topic.
Didn't God create you perfectly as well?
No.
So when they tell you to go get your 5th shot, are you going to wear your NASA shirt at the same time?
I think we should avoid this topic.
Okay, it's good. It's good. I just wanted to know because I really like you and I like talking with you. Hey, we've talked about this 3 times. This is going to make 4, so forgive me.
Sure.
The Trans-Australian Railroad,
300 miles long.
301 miles long, exactly. You remember our conversation. 301 miles long. According to a ball with a radius of 3,959 miles, 8 inches per mile squared, in order for that 301 mile section to fit, it would have to bend 11.42 miles, or if my memory is right, 60,297 feet.
Correct.
You have told me in the past, tell me if my memory's bad because I'm about 10 years older than you are. Tell me that you said that over that 301 miles that you could take an 8-inch section for each mile. Do that 301 times of 8 inches. Do that 301 times, which would be 200 feet, 8 inches, and it would work. You told me there's some linear equation that, if you could show that could say why the Earth has to bend 11.42 miles over 60,000 feet. But you tell me it works 8 inches, 301 times, 200 feet, 8 inches. Can you tell me how that works?
Sure. So basically, this is an exaggeration, but from the perspective of the beginning of the railroad, then over the next 301 miles, the end of the railroad will have bent down 11.42 miles. But if you're looking at individual pieces of that, just in the bare fact that you're using 8 inches per mile squared, that squared means that it's not a linear equation. It's a parabola basically. And so if you divide it up into littler pieces, like if I say, oh, what about this one piece right here? If you split it up into 1 mile sections, then each mile only has to curve 8 inches, right? Each mile curves 8 inches. But the thing is, from the next mile, from this perspective, it's a little bit tilted. And so this one only has to curve 8 inches also. And then this one curves 8 inches, then that one curves 8 inches. So that's why you can't just take each mile and multiply it by 301 and expect to get the 11.42 miles. So you're right. If you take 8 inches and multiply it by 301 miles, it doesn't equal 11.42 miles. And that's because you're looking at the difference between a linear equation and a parabolic equation, a nonlinear equation. Exponential.
So if I get you right, so everybody knows and everybody hears and people hear it on YouTube in the future, you just said that, as you've said to me 3 times before, that you can take over 301 miles, you can take 8 inches here, 8 inches here, 8 inches here, 8 inches here, do that 301 times, and it fits around your ball of a radius of 3,959 miles. Is that what you're saying?
Right, because the effects are cumulative.
I love you, Matthew. I love you. If we do, for everybody who's listening, if we ignore the parabola, which is good down to 1,000 miles, if we forget the Earth curve calculator, which NASA mainstream science and land surveyors use, if we forget 8 inches per mile squared and forget the squared and just do 8 inches, 8 inches, 8 inches, 8 inches, 301 times, and it comes to 200 feet, 8 inches, your Earth wouldn't have a circumference of 24,901 miles. It would have a circumference of 7,495,201 miles. You wouldn't have a radius of 3,959 miles. If you threw off the squared, you would have a radius of 1,191,659 miles. Matthew, you wouldn't be off by a factor of 1, 2, 5, 6, or 10. You'd be off a factor of 301. And I'll even give you this. You've even told me you can take 500 yards at a time. I gave you a mile, 1,760 miles. Let's half that. Let's go to 880. Let's do that 880. You double.
You'll end up with the same thing. I get it.
No, you double it. You don't go 1.191. You go almost 2.4 million miles for a radius and almost 15 million miles for your circumference. Matthew, I know I didn't, I know I need to go back to school because the more schooling, the more education I got, the more chance I have to believe like you. I get it. I'm a dummy. I'm a flurf. I'm a flat tart. I'm mentally ill.
I've never said any of those things.
Which I know I strawmanned you. Forgive me. And I've been called all those things since I learned the truth. Matthew, I didn't become a stationary topographical plane believer, a true earther. because I enjoyed being called a flat tart. I enjoyed being called a flurf. I enjoy being called mentally ill. I enjoy being called dumb. I enjoy being called stupid. I enjoy and on multiple times a day, perhaps, because I enjoy it. Because for 60 years of my life, I thought I lived on a ball. But the only reason I changed was because the truth took me there after I found out that tiny invisible microbes don't cause illness, disease, and death. But we can't talk about that, even though we think we live in a free country. God bless the USA. And so my truth brought me to this stationary topographical plane. I would not be where I'm at today if I appeal to authority, consensus, popularity, money, regurgitation, diploma. I wouldn't be there. I decided to think for myself. The eyes are useless, Matthew, when the mind is blind. We are all born into a prison system that we are unable to see, therefore we can't get out of. One of the greatest gifts, Matthew, you can give yourself and everybody else is the ability to think for yourself.
Right. Thinking for yourself is great.
Many people,
but you might get it wrong.
I think many people look into what they're going to eat for breakfast, dinner, and lunch, and that's all they think about independently for themselves. Because they have been told they live on a ball. They have been told other things. We can't talk about it because, hey, well, we live in a free speech country. Yeah, but we can't talk about it.
Okay.
Go ahead.
Go ahead.
Go ahead. All yours,
yes,
my friend.
So I like the idea of doing your own research, thinking for yourself, all those kinds of things. However, I would respectfully submit that just because one person thinks for themselves doesn't necessarily mean as a guarantee that they will come to the correct conclusions. So it's good to have intellectual humility that thinking for yourself, you still need to hold things lightly just because you thought about something. I'm going to try and explain. It'll take me a little minute, so if you indulge me a minute, let me explain the difference between cumulative linear adding up of those 8 inches per mile squared versus a parabolic or exponential function. So you are right that if you take 8, so you did all that math correctly, so good job. If you take 8 inches and multiply it by 301, then you will only get 200 feet over the space of 301 miles. But that's not what we're saying. We're not saying that you're adding up linearly. We're saying that you move 8 inches and then it curves a little bit, and then that curve is added into it because it's an exponential function. And so let me give you a simple analogy that some people understand because it's from finances and money. If you save $80 per year instead of 8 inches per mile, let's just say you save, let's say $80 per month, and you save that for 10 years, and you just put it in your mattress, you will have 80 times 12 times 10, you'll have $9,600, right? But if you take that $80 and you put it in some interest-bearing account or in the stock market that has a general, interest of about 8 to 10 to 12%, whatever. If you basically have the magic of compound interest, then what happens is that as you leave your $80 in there, it actually earns more interest, and you start earning interest on the interest, and then interest on the interest on the interest, and so you end up with way more than $9,600. In fact, if there's any young people listening, if you're in your early 20s and you save even as much as $50 or $100 per year, you can build that up to be $1 million by the time you're 65 without much trouble. I mean, assuming that the economy doesn't collapse and the zombie apocalypse doesn't happen. And so the magic of compound interest happens because you have an exponent in there. And so your wealth grows exponentially with saving. Same thing if you're on the wrong side of the equation, if you're accumulating credit card debt or you have a house loan, you have to pay more and more just to get, you're paying a huge amount of interest from the beginning. And so that's an analogy, a mathematical analogy of how linear growth is different fundamentally than exponential growth. And what's happening with the railroad thing is the same thing. You're correct in doing the linear growth. The way that you did it is correct. But we Globers are saying it's an exponential growth, 8 inches per mile squared, and that squared makes it exponential. And so that's the basic idea of why it's reasonable to say that those 300 miles could be, the 300-mile long railroad could be curving at 8 inches per mile squared.
It can't. Non sequitur. I actually say, my friend, your explanation was insanity, but we'll let it go at that.
So we should ask people who understand mathematics a little bit to arbitrate between whether my explanation was reasonable and understandable, or whether it was insanity.
I think people should understand, on a ball of 3,959 miles, that over 301 miles is 11.42 miles, 60,297 feet. And if you apply 8 inches per mile squared, your explanation is insane.
Anyway. So you're correct. If you do the math incorrectly, then it won't match.
Hey, I want to do this because I've seen other people do it. So indulge me for a second, Matthew. Okay. You know what this is? I hope you can hear it. You hear that?
That's carbon dioxide escaping from a high pressure to a lower pressure.
Yeah, that's the second law of thermodynamics, which according to your globe advocates, our Earth is uncontained, but you can't have gas pressure without a containment or a container. So I just showed you that your little fairy tale world of going up, 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 and up, and not having to worry about a container until you get to the vacuum of outer space is nonsense. And then when you come back, you have to worry about the container. But you know what? NASA would never lie to us. And I don't know if you own a NASA shirt or not, but you should wear it proudly, Matthew.
So So you're mostly right that the gas expands into the room, like that carbon dioxide in your Coke container expanded into the room. However, there is a slight difference. It expanded a little bit more towards the bottom of the room than the top of the room due to the weight of the air. So I can see your ceiling in your image there. And I don't know if you know this, but the air pressure up at your ceiling is slightly higher than slightly lower than the air pressure at the bottom of the floor of the room that you're in right now. And sensitive enough barometers can tell that difference. And so the weight of the air is the explanation of how air pressure can exist without a container.
But there's still pressure, right?
There is pressure because of the weight.
There is pressure. There is pressure, but in your fairy tale globe, you can go up, 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 and pretty soon you'll be in the vacuum of outer space.
Right.
But coming back, you have to worry about getting it right by about this thickness, or you burn up, or you go out into the vacuum of outer space and you die.
Yeah, I'm okay
way.
with you calling. I'm okay with you calling the idea that air has weight a fairy tale. I'm just telling you that I don't think it's a fairy tale. This thing about the paper that he's talking about is that when the Apollo 13 astronauts had to come back, instead of using rockets to propel them out of the Earth's atmosphere, it's more efficient to use friction to come into the Earth's atmosphere. But if you come in too steep, it's too hot and too fast and could burn up. If you come in too shallow, it might not slow you down enough and you'd skip off the atmosphere and bounce off of it. And so the newscaster in 1970, whatever, was saying, by analogy, compared to a globe, that the space that they're aiming for is as thin as a paper, relative, like not literally as thin as paper, but very small compared to, the size of the Earth. And so that's an apt analogy, and that's what he was talking about.
Hey, I don't know how much time we have left. I need to spend $20 on the clock.
Yeah, we started about an hour and 45 minutes ago.
Oh, so we're getting close.
Near the end, and I'd be happy to talk about something else, or when you are ready to stop, then we could open it up.
Hey, we touched on refraction. We didn't get all the way through it. The only thing I can say about refraction, refraction is a hindrance on our view, and it only works on a linear surface. So if something's going away from you, you think it's curving around your ball. It's not a linear surface, and it doesn't work on your ball. So refraction is something. You say light can bend. I say it doesn't.
I'd say the
Well,
path of light can bend to make you
yeah,
happy and say it that way.
Well, we'll let that go. Here's something I want to share real quick. You have your kinematic equations. The kinematic equation is a set of equations that describe the motion of an object with constant acceleration. We're told, Matthew, that gravity, 9.81 meters per second squared, agreed upon average. But with gravity, you need to know the radius of the Earth. I think you would agree with that.
No, you can just measure it. You can just measure the gravitational effect. We did that in my physics class.
But within the equation of gravity, to get to gravity, 9.81 meters per second squared, you need to know the radius.
No, if you're just using gravity on Earth, you don't have to know the radius at all. You just measure what gravity is.
Well, everything is based on 3959.
No, the path of a cannonball on Earth is based only on the measured gravity. You don't have to know anything about the radius.
Your gravity equation, 9.81 meters per second squared, would be different if the radius was 5,000 or 3,000. Do you not agree
that's not
with
true.
that?
No, yeah.
Do you not agree with that? Do you not agree with that?
Yeah, the radius has nothing to do with the measured value of gravity. Now, obviously, if you're asking where gravity comes from, then the size and density of the Earth would influence it.
Gravity, you need to know the radius. You need to know the weight. What's fascinating is with the weight of the Earth, we're told that is 13,170 billion trillion pounds. That's what we're told. And then we're told the density of the Earth.
Big numbers don't scare me.
I tell you what, when the average normie hears big numbers, not you, but when the average normie hears big numbers, they go, "What's for dinner?" When the average normie hears those kind of numbers, they go, "When do my Dallas Cowboys play?" They totally turn off and they let a scientist tell them what to think or what to believe.
So they should instead be incredulous and say, that can't be true. It's too big of a number.
It would be great if they could think for themselves, but they don't. Okay. And then you have to know the density of the Earth, which is 5.52 grams per cubic centimeter. So you got to know all these things. You got to do all these mathematical, gymnastics. It's amazing that we're told
just
this.
Ignore it and measure it. Ignore all that and measure the acceleration of gravity.
Perfect segue. Matthew, thank you for the segue. Let's measure ourselves. So let's measure
You can drop
ourselves.
things. That's the easy way to do it.
Yeah. Oh, Matthew,
we did this in physics class.
Matthew,
we did this in my physics class when I was a
senior. You're disproving Newtonian gravity. Thank you. Hey, and definitely bending and warping space-time. Matthew, you can take height, the object above the ground. You can take time that it takes to hit the ground. You can take A, which is the constant acceleration, downward, and you can take the initial velocity, which is generally 0 when you're holding something up here, and then drop it. You can go through h equal 1/2 at squared plus vt. You can take the kinematic equation and simplify it to h equal 1/2 at squared. Then you can solve for a, and then you can plug in what your actual experiment was, how high it was, how much time it took to drop. You can do all that. At that time, you, not a scientist, can do it. Right. And when you do all those things, whether you do it from a garage, whether you do it from a 10-story building, whether you do it, do it yourself, maybe with a friend.
And I recommend people do this. This is a great type of experiment. Do your own research.
You come up when all your work, you don't have to know radius of the Earth. You don't have to know the weight of the Earth. You don't have to know the density of the Earth. You just have to know those 4 things. And anybody can do it.
Right.
They don't have to listen to a scientist. And you know what? When you do that, you come up with, basically, without even trying to get a closer number, you come up with A, acceleration. You throw out the G, which doesn't exist, gravity. You get A equal 10 meters per second squared. You come within 2%. You haven't even tried to get closer. You come within 2% of 9.81 meters per second squared gravity. And then, Matthew, you can throw out the concept that gravity keeps people and water to the sides and the bottom of a spinning, watery, curvy, bendy ball. You can throw that all out, Matthew, and then you can actually
let me get this right. You don't like G equals 9.81 meters per second. So if I just replace it with A equals 9.8 meters per second, you're okay?
Replace G with
A, and that solves everything?
You replace G with A, and you don't have to have a scientist tell you why things go boom, boom to the ground.
Right.
And I gave you 10. I gave you 10. A equal 10 meters per second squared, and I didn't even try to get more specific. I could get more specific, but my friend and I looked at something from a 10-story building, dropped it, and we came up with 10 meters per second squared, and we didn't even try. We didn't have to rely on the radius of the Earth, the weight of the Earth, the density of the Earth. We did it ourselves. You know why we did it ourselves? Because we didn't appeal to science, authority, consensus, majority, regurgitation. We didn't appeal to any of that stuff. We appealed, Matthew, maybe for the first time in our life, to the ability to think for ourselves. Because we are told at age 5 that we live on the spinning, watery, curvy, bendy ball. And by the time we're 10 years old, we're 5 years into our indoctrination. And if we decide to go against that, the teacher laughs at us, our students laugh at us, our family laughs at us, and our friends laugh at us. It's called indoctrination, and it is the most insane. And I know people, you aren't going to like this. It's the most satanic thing. John Calvin was right. You will see people that are so deranged that they believe that the earth spins or moves around the sun, and when you see such people, you will consider them devil possessed, and you will keep them in the mirror so you can see what you don't want to be. Now, that's a little bit too deep for people. It's not my fault.
Okay, so I commend you for going out and doing your own research and measuring the acceleration that happens when you drop things. I think I wish more people would do that. I think it's an interesting exercise in physics and mathematics, and so good for you for doing that. However, I don't think that that understanding scientific explanation for where that comes from is necessarily satanic. In fact, I think it's doing our God-given duty of looking at the earth and trying to figure out God's creation to bring glory to God and all that type of thing. But again, I don't want to get into biblical cosmology. So I reject the idea that the globe is satanic. But I am glad that you went out there and tried all these things yourself, and measuring the acceleration when things fall is an easy and simple thing to do. So good for you.
Hey Matthew, why did it take Artemis to take 6 days to get to the moon, where it took
gravitational mechanics.
Where it took Apollo 11 3 days? Do we have a speed
different
limit
gravitational mechanics?
Do we have a speed limit in space now?
No, there are different. There's different ways to solve the equation of how to get to something using gravitational orbital. Sorry, I should have said orbital mechanics.
Have we advanced
complicated equations, but they're solvable.
Have we advanced technologically since 1969?
We certainly have. That's why Artemis can go up there on remote control and do the whole thing without any humans in it.
But it takes twice as long to get there.
It's more efficient. That trajectory is more efficient according to orbital mechanics. So
are they trying to get better miles per gallon, or is there a speed limit up there?
Miles per gallon would be a weird way to do it, but I think you probably could divide the number of miles by the number of gallons of propellant. Sure.
One of the little things I have in the general chat text is a picture of is a little gift. It's not a gift; it's actually a small video that shows that what the moon looked like back in 1969 photography to what the Earth looks like from the moon in 1969 and what it looks like in 2022. Did the Earth get smaller, Matthew, over 53 years?
It did not.
I mean, did we go from 8,000 in diameter miles to like 1,500? I mean, nobody told me. Did they tell you?
No, the Earth is the same today as it was in 1969, same size.
So why isn't the picture the same size from 1969 to 2022?
Optics, camera lenses, distance, the way it works. I don't know. We'd have to look at the specifics of how it was taken. I mean, I could show you two different pictures of the Eiffel Tower, one where it's this big in the camera and one where it's this big. I mean, maybe they zoomed.
So we should trust NASA?
No, we should say that maybe they might have twisted the zoom on the camera, not that the Earth changed size.
Yeah,
The Earth changed size because they zoomed in more.
I'm just a dumb flat earther. I need to go back to school, and if I went back to school, I probably would become a glober again. God bless me. Thanks for the advice, but
Okay, but if I zoom in on the Eiffel Tower, it doesn't get bigger. Or if I can squish it with my fingers, that doesn't mean it's smaller than my fingers.
Well, the fun thing about the Eiffel Tower,
camera stuff.
The fun thing about the Eiffel Tower, I can actually go there. I can't go to the moon. You know why? It doesn't exist as you say it does.
The moon doesn't exist.
Outer space is impossible because the inverse square law of light, second law of thermodynamics, and Newton's third law of motion. But to keep your outer space monkey religion alive, you can go against how water works here on Earth. You know how water works here on Earth? You can go against that physics, and then you can go against the second law of thermodynamics. Hear that? You can go against the second law of thermodynamics, and everything's good. You know why everything's good, Matthew? It's because you kill God every time you go into outer space. And Nietzsche was proud of it, and we have people that are proud that they get to kill God every single time they go into outer space.
So we're running out of time, and that sounded like sort of a summary ending statement for you. So
I have one for you. You go ahead.
Okay. Yes. So I think all the things you brought up, the second law of thermodynamics, the pressure without a container, all those kinds of things are explainable on the globe Earth theory. And just to sort of sum up what we were talking about, since we're ending here, I will say that those three things that I brought up, seeing the top half of the sunset and not the bottom, the constant size of the moon, the full moon during the night, and the seasons, the symmetry of seasons in the northern and southern hemisphere. Those three things are best explained on the globe model rather than the stationary topographical plane model that Jim has been saying. And so therefore, I recommend to people that they should adopt belief in the globe system and give up belief in the flat earth system, because it does not adequately explain these three things and a whole host of other things. So take the rational route, look at the evidence, do your own research, and look at this closely, and I think you'll come to the same conclusion that I did. Thank you.
Thank you. I'll leave that general chat text up for, I asked Gio, or I said I'll take it down here in time, so I don't want to clutter up his general chat area. But people want to take a look at the 6 videos, the examples of the moon rising, star patterns with a dome, Apollo 11 pictures, blast crater shadows, 61 miles, 24 miles for Baumgartner and for Bezos, Earth curve calculator, Chicago skyline, examples of flat, the Foucault pendulum, that Einstein basically said, I can't see any motion of the Earth from on the Earth, so that takes care of the pendulum. The philosophy questions, the 20 quotes that I'm not going to bore you good people with, and the videos. If you want to look at that and you make your own opinions, make your own decisions. If you want to share them with people, please do. There's not much better Christmas gift to give somebody than the truth, because the truth never hurts anybody. So give them the truth, let them decide. Matthew, you spent 4 hours with me the last 2 weeks. I really appreciate you much. And
likewise, I had a fun time. This was a pleasant debate. I mean, we got a little bit animated here and there, but at least we weren't yelling at each other, and the moderator didn't have to mute either of us. So that in itself is a success. I would say the debate's over now. I'm going to turn off my camera, but I'm going to stick around, and I'd be curious to hear from some of the audience if you have any questions or just comments. Yeah. Is that good? You want to stop it here?
Yeah. Thank you, Matthew. Austin said it best last night. I asked him, "What's the chance of Matthew, becoming a stationary, flat Earth or whatever?" I might have said, 1 being no chance, 10 being, he's got a chance to become one of us. And Austin thought about for about a half second, and he said 1. So
I'd say 0. So I agree with him there. Like, there's no chance.
I can't improve upon Austin's answer last night. But thank you, Matthew, for your time.
Nice. I'm glad we ended on something we agree with. Okay.
And Merry Christmas to you.
Merry Christmas to you and to everybody. Thanks for listening.
Yeah.
Okay, I'm off camera, but I'm still here. I'd be curious to hear, in particular, Kosho, what's your opinion of how things went? Would you mind sharing? Oh, I don't know if Kosho's there. I see him there.
Yeah, it was a good discussion, debate there. So, yeah, I just opened up the settings, so everyone should be able to open their mics. Although, I don't know if Discord had updated this, but there is it's like you almost have to leave the room and rejoin, or I have to mute and unmute you to, after you're already in the room. So, let's see.
I saw Kosho's mic flash red for a sec. I don't know if he was trying to.
Actually, back. Good job, guys. I like how Matthew is always very chill to the whole debate.
Yeah, I would agree. I thought you held your composure very, very in a very stable way, Matthew. That was awesome.
Thank you. Appreciate that.
Especially when you said you had a monkey religion. You're just like, cool, yeah, okay.
I've heard that plenty of times, so it doesn't bother me. Yeah, I don't think it is a monkey religion. I think it's the true religion, but of course I understand that you would disagree with that.
Yeah, so if anyone has any question or comments, if you're still muted, you may have to just leave the voice channel and rejoin, or if you put in the text chat, we can mute you and unmute you. That's kind of how it seems like Discord, unless they've updated it, it's how Discord seems to work. So, but yeah, if anyone has any questions or comments or anything, feel free to jump in
I have a question for Matthew.
Sure.
Hey, Matthew, I was just wondering, because I heard yesterday you have a big subscriber base. I was surprised to see how many subscribers you have. Congratulations, by the way. Yeah.
Thank you.
I was wondering, are you going to show this to your subscribers? Are you going to put this debate out on your channel?
Probably not. My channel is more educational content and pranks that I do in my math class, and it's more scripted, and these kind of unscripted things don't work well with those subscribers. But I'm happy to link to it, and promote it other ways.
See, the reason I asked that is because I got that impression last night when you were speaking, like somehow you're trying to hide this kind of information.
Oh no,
are you embarrassed about it, or
no? There are actually a handful of videos on my channel about flat Earth, and in the description of those videos, I link to the Discord. Well, back in the day, it was the 24/7 Discord server. So yeah, I'm not hiding, and I even quote some people from that server and have links. So yeah, I talk about it.
Okay, fair enough. Final question. Would you be opposed, let's say, for example, to have a guest on your show? Let's say Witsit or somebody like myself to discuss the alternatives to the current cosmology. Would you be opposed to such a thing, or
I'd be happy to talk with you guys. I don't have a show. I don't know what you mean by my show, but I'd be happy to talk with you guys on Discord and put it out there wherever.
Oh, okay. You don't have like a YouTube channel. You don't do like live stuff on your
No,
YouTube
I
channel?
just have a YouTube channel where I occasionally, in fact, it's been months, where I occasionally put educational content out there that's sort of roughly related to mathematics. So, for example, I did the mathematics of Bitcoin, how PGP works, how the SHA-256 algorithm works. That's the kind of stuff I'm interested in.
Cool. Maybe we can arrange something one day because I like your demeanor. I like the way you talk, and I think we can have a very constructive conversation. So maybe we can do that in the future.
Agreed. I think that would be interesting. I would like that.
Cool.
Why don't you ask him your questions about the escape velocity you were asking last night? That's
Oh, the escape velocity for the Artemis. Yeah.
you seem very confused by that. Maybe you can straighten you out.
Is this how you think you should come in? I think I'll save that for another time.
Okay.
Because Matthew seems like a nice fellow, and I don't want to start something with you in between Moyak. No,
I'm asking you to ask him. I'm not trying to get into it with you. I want to hear you.
Yeah.
Well, that was a topic that they
Wait.
did brush on that topic during their debate, but yeah, if we're gonna in terms of jumping into like a whole new thing, once this stream, once we finish the kind of question and answer and comment, then I'll probably end the stream and then we could start up a new live stream. But
I thought you had ended the stream when we finished, but yeah.
no, I figure we could keep it going for any additional kind of either
sure,
questions or comments related to the debate.
I had a question.
Okay, go ahead.
The guy showed a Coke can and he released the pressure. How much pressure is in a Coke bottle? Does anybody know? Pounds?
I'm gonna guess like less than 1 pound per square inch, maybe 1 or 2.
Oh no, about 90.
90 pounds?
Yeah,
per
they're
square inch?
rated. Yeah, they're rated for about 90 psi.
Oh, they're rated that high, but when you open one up, how much is actually?
It wouldn't be 90. It's probably it's not more than your tire pressure. Tire pressure is about 40.
But if you shake it up and stuff, it's going to hit, it's going to go up quite high.
Sure. They wouldn't want it to be too high because then it could become dangerous, right? Like shoot across the room and hurt somebody.
I don't think it'd be more than your tire, though, guys, would it?
Well, they have to be built such that they will, like 3 times the safety factor, withstand any pressure that would be generated in the can.
Yeah.
Okay, let's just say the average pressure is 30. Can we say that when you open it up? If it's 90, it would explode on you. That's one of those situations where it blows up on you. But let's say it's a regular soda can, not shaken. It's about 30
Well,
pounds.
I mean, I think that the point is that 10 thousandths thick Coke can withstands like many times more pressure differential than the spacecraft would have to.
That's right. That's true. However,
Wait. You said the Coke can it can withstand what the ISS can withstand? Is that what you said?
Way more than what the ISS has to stand.
Twice as much.
Yeah, that's a good point.
You guys must be crazy. But that wasn't my question. My question was, can you dig a hole in the Earth and then go down in that hole and get 40 pounds, get Coke can pressure? Has anybody done that?
Huh?
What?
You mean the pressure gets higher when you go lower? So if you go into a mine or a cave under sea level,
Can you get 40 pounds of pressure going into a hole into the Earth?
Yes. Well, no, I just did the calculation on this the other day, and I found like I think it was like at 50 miles down, which we'll never get to, but 50 miles down, I think it was another bar.
Yeah,
how much pressure at 50 miles?
Yeah, the atmosphere is about 60. We tend to think of 60 miles, so you need to go at least 60 miles down to get double the pressure.
Oh, yeah, that makes sense.
Yeah, that would be correct.
So we can't get that far.
When I continued the calculation down to the center of the Earth, it got to like liquefaction pressures and stuff, hundreds of megapascals.
Yeah, but at the center, there'd be no pressure.
No, there would still be the pressure of all the weight above.
Oh, that's true. You have the other way above you. Yes, sorry, it's true. Yeah.
Cool story.
So which one is right? This is a double speak here. Who's right here? No pressure or a lot of pressure?
Not sure. We're speculating.
He agreed with me right after I expressed the fact that it had all the weight above. He agreed with me.
Yeah, because all the bits. Yeah, because all the bits on the surface are still pushing down on the bits towards the center, and all the say the bit in the middle is also pushing down towards the center. But if I were to open you a hole in the middle and stick you there, you would float.
Oh, it was just. I'm glad you mentioned that, Rumpus. So now that, so the floating part exactly. So we got a crazy amount of pressure, but you float at the center. This
Now,
is
hold
what
on.
you guys.
You didn't. I did express it quite clearly. I gave you 3 points. The surface is pushing down towards the center. That's pushing down. The bit in the middle is also pushing towards the center. So I gave you quite a long explanation there as to why those 2 things are pushing into the center.
So are you saying all those combined forces to the center are canceling out or something?
No.
How do you explain the floating?
Because if you have 2 forces pushing towards one another, that doesn't eliminate them. You'll get crushed, like being in a vice. It's like saying one arm of the vice is pushing one way and the other arm and the other vice. That doesn't cancel out. It means the thing in the middle is crushed. But the point is, if I was able to give you a little protected shell in the middle of the center of the Earth, you would float in it.
Of what? A protected shell of what?
Well, whatever, something will protect you from the pressures of the things we're talking about above from the surface. If I could protect you from the forces above you, then in the center you would float.
So are you suggesting that
That's
if you
not the
build
current
like
model,
a cocoon, like a cocoon bubble of cement, somehow you're going to start floating in the center of the Earth?
Yes.
Oh my word!
Yeah,
You
but that's
guys
not the
heard it.
current model, though.
Well, if you try and deal with all the forces that are involved, you'd have to come to the conclusion you float.
No, you
Yeah,
would
there is
come
no
to that
forces, though.
conclusion.
There
A
is no
sane
forces,
person,
though.
yeah, a sane person
It should
would
be
not.
obvious to you, SE. All the force around you, you've got the same amount of force above you in all directions. They cancel out, and so there is no net force on you.
You just contradicted yourself
Oh
with
my
the
God.
vice. Hold on.
Right, let's try it again.
No, now my turn to talk, Rumpus. You use the
Yeah,
vice
you didn't
example,
understand
right?
what I said. I'm going to have to re-explain it because you didn't understand. It's the force of the things around you pushing down, because there's a force at the top of the surface and the middle, all pushing down towards the center. So you need to be protected from the forces that are transmitted from the earth and material above you. Once you're protected from those crushing forces and you're not actually in contact with them, then you're only then subjected to the gravitational attraction of those things away from you. And if you're
So let
that
me
will be
see.
zero.
Okay, let's see if I got you correctly now. You're saying all the combined forces at the center of the Earth, which is a sphere, if you were to build some sort of cocoon around it, a cement structure, which I can't even imagine, but let's say we do that. You expect us or people to believe that somehow doing that, blocking all those forces, that you will float in the center there.
That's right, because there's no forces acting on you. The gravitational mass around you is symmetrical in all directions, and you're being pulled like it's like being subjected to, in a oh god, a pulling competition with a rope, whatever it calls, tug of war, and everybody's pulling you in the same direction
or it's like floating in water.
Yeah, and so they're all pulling in the same different directions, but they all cancel out, so the net force on you is zero.
Well, that's some fantastical thinking.
I just don't understand why
Well, it's just
Rumpus
basic
comes in
vectors.
and somehow takes over. You know, we were doing questions about the debate, and all of a sudden this guy makes all about himself.
Sorry, yeah, I'm distracting from the debate. Yeah.
Yeah, fantastical story. I mean, let's get back to reality.
It is reality. It's a simple vector addition.
Anyway, coming down to the debate, if I can make some observations, if I might. It continues to show a white swan, what we would call a white swan images, where the horizon, on his mind, it calls an obstruction to the sun. That has been debunked in 1st of January 2020 with what we call the black swan. You just need to show one image that the horizon is not at 1.2 times the observer height in feet to debunk the notion that the horizon is physical and there's any physical obstruction to it.
No, you don't, because
I mean, there's observations to prove that the horizon is not physical.
My response is that I didn't say where the horizon was.
That's the first one.
Yeah,
Sorry?
I didn't say where the horizon was. I was just saying that it looks like if you look at the solar disk, the bottom half is not visible, so it must be blocked by something. There's no other explanation.
But there is also other images that contradict that what you were just saying, where the horizon is not obstructing on a certain time of the day, a certain times of the year. The horizon is not obstructing
Right before
physical
the sun
things.
sets, it's not. Yeah, before the sun sets, it's
The
not
distance to the horizon, will vary throughout the day and throughout the year. Yeah, I'm sure you will agree with that. The
I
horizon
wasn't
is
saying
not a
anything about
physical
the
thing.
distance to the horizon. I was just saying it looks like the sun is blocked.
Yeah, but the point here is that the horizon is not physical anymore. So welcome to Flat Earth. It was pointed out to you, and you are welcome.
That
to the
isn't
Flat
that
Earth.
welcome to Flat Earth statement.
Well, you need to write the horizon to be the physical obstruction that you were trying to bring up with the sun when it's not. Yeah, it's not physical
the statement
obstruction.
that the statement of where the horizon is different than the statement that there is a horizon blocking the sun. Those are different things, and so I don't care.
You asserting a blockage.
Right. I don't care about the distance. I'm just asserting that
we have images where the horizon is not blocking.
Yeah, 10 minutes before sunset, it's not blocking.
Not sunset. We have platforms that we can see sometimes obstructed, sometimes not obstructed.
Sure, different comment, different idea. We could talk about that, but you were talking about the sunset. The sun is clearly blocked from the bottom half only.
The sun is blocked. Well, you cannot see for whatever reason, but to say that is due to Earth curvature, I mean that's a red herring.
It's a fact.
The horizon is being debunked as being Earth curvature. 2020, 1st of Jan.
No, you're getting confused about refraction.
No, refraction is not geometry. Anyway, we're talking about
that's exactly right, but it
moon
changes what you
angular
can
sizes.
see.
Yeah, it was brought up also moon angular size. We're talking about the apparent size of the moon and its position on the sky. We're talking about elevation angles. That requires a flat plane as well.
No, it doesn't.
So how does the moon stay the same size all throughout the night?
It doesn't stay the same size. We don't know the size of the moon. Do you know the size of the moon?
It's no, the angular.
That's a big claim.
The angular visual size is the same all night long. The visual size.
The apparent size. The apparent size. You mean the apparent size?
The apparent size is the same.
The apparent size of the moon, when it's measured to its position, elevation angle, requires a flat plane.
No, it doesn't. You just made that up.
Yes, it does.
That's a separate statement. Maybe it does, maybe it doesn't. But the plain fact of the matter is that the apparent angular size of the full moon stays the same all night long. What's your explanation?
Explanation is like you just said, angular. Yeah, for you to have that angle, yeah, it requires a flat plane.
Okay, so you're backing up and disputing that idea. But my question is, why is it the same size? I don't care about.
It's not always the same size. What size is that? Which size would that be?
About
you
half a degree.
For you to say that it's bigger or smaller.
No, it's about
half of a degree.
0.
What's that?
5.
It's about 0.2 degrees all night long.
No, 0.5.
Sorry, 0.5. Yeah.
Is that the size of the moon?
It's the apparent angular size of the moon all night long.
Angular. Yeah, it requires
almost every day.
The fact that I use the word angular seems to trigger a specific.
No, it doesn't trigger anything. For you to find the angle, for you to find these sizes, it requires a horizontal plane for you to establish these things.
No, you can use.
I understand exactly what you're saying. These things are not done on a sphere, though.
George, you can let him talk. Come on, let's have a conversation.
Yeah, to determine the angular size of the apparent size of the moon, you don't have to know anything about the horizon. You just look up there and measure it, maybe with the sextant, maybe with some other tool, to determine how big the moon appears. That's what we're talking about. The size of the moon does not change appearance.
Matthew, this strange person thinks that depending on what you're standing on changes what a sextant would give you a result. He thinks if you're standing on a hill or a slope, it changes the angular size of the object you're looking at. It's very strange.
It changes the angle, but not the angular size.
I didn't say that.
No, it doesn't. He thinks it changes the angular size. He thinks you can't make an angular size measurement just because you're standing on a hill or a slope.
Red herring.
Yes, you can. Yeah, you can. Doesn't matter what you're standing on to use a sextant.
A sextant is a instrument to establish angles. Yeah, elevation angles to be more precise.
Yes, between 2 points. Yeah. Between 2 points. Yes.
Yeah, you can use it for elevation angles, but you could also use it to determine the angular size of the moon.
Yeah, it can also. Yeah, exactly. You will need those angles to establish that.
don't need to care about what you're standing on.
Exactly.
No,
You need to care about what you're standing on. You just need a horizontal plane to do so.
No, you don't need a horizontal plane. You don't
Yes,
need
you
to
do.
care about what you're standing on because
Nope.
you're measuring the
You-
angular sextant
you-
at two angles.
You need
I
an
could use it
elevation
standing on a
angle,
boat,
which
George.
is a right angle.
George,
It's a right
you
angle
could
from
use
a horizontal plane.
you can use it
Not
standing on a
necessary.
boat. You can use it standing on a hill. You can use it standing
In
on
a
a flat
valley?
ground. It doesn't matter where you're standing.
It matters if you're using the surface of the Earth, which
You're
is
not
what
using
the
the surface.
sextant
You're
and
measuring
the
an
astrolabe,
angle
which is
separation between two
what the
things.
sextant and the astrolabe used to do, or it still does if you use the instrument. Yeah, you need to use the surface of the Earth in order for this instrument
No,
to
you
work.
don't. Not to measure the
Yes,
angular
you
size of
do.
something. No, you don't. You just take the
No,
angle
I'm
of the
talking
top and the
about for
bottom of something.
navigation.
The
I'm
surface
talking
has
about
not got involved in
navigation.
that calculation or observation.
George.
Yeah.
I just basically I don't have to look at the horizon. I don't need to take any measurement with this. I can take a protractor, a plumb bob, dangle it off, or I don't even need the plumb bob. All I have to do is go to point A, tip my protractor down to point B, and I'll be able to see the angular size of something. Totally independent of where the horizon is, whether I measure the horizon. I can tell you the angular size of anything in my room without finding the horizon. I don't understand what
you use a protractor,
you think the necessity of the horizon is in this. Yes, I can do it with a protractor.
Yeah,
Absolutely insane.
that's exactly how it's done. Yeah, a sextant is pretty much that. It's a glorified protractor. That's why you measure the angle. But the zero line of the protractor is equivalent to the surface of the Earth, which is the
No, it isn't.
horizontal
You
plane
can
we
point
are
the
talking
zero
about.
line at the bottom of the moon. You can point
But
the
that's how
zero at
it's
the bottom of
done.
the
It's
moon, and you can
used-
measure the angle to the top.
No, that's
the
not how
surface has
mariners
not
use. No, it's
participated
not like
in
that.
this observation at
But
all.
you can.
Mariners,
George is
they
right.
use.
The whole
Mariners
point is
don't
you
measure
can.
the size of the moon. Mariners do not care about the size of the moon. They don't measure it that way. Our
There you
point,
go.
George, is
Don't
that you
need to.
could use it to measure the size, the angular size of the moon. That's all.
Right.
I mean, you could
You could either use that
measure the
like
angular size
looking
of
at
the moon.
objects in the distance. You could
Let-
use
let's
that.
say
You measuring
You are
the
measuring
size of
elevation
a known
angles to the
object
moon.
and tell
You are-
how far away you are.
Now you're measuring elevation angles to the moon as it moves overhead.
That's a separate question. We're talking about
Nope.
the size of the
that
moon, not
is
how high
that.
it is.
It
Yes,
is,
but it has
George.
to do with it, isn't it? And
No,
closer to the horizon the moon is, bigger it will get.
No, it's the same size.
no, it
That's the whole
doesn't.
thing.
No, it's not the same size.
Have you done
Not
this?
always.
I
I've-
have.
Yeah, it's not
I've
always the same
measured it.
size.
It's about a half a degree at the
Not
horizon.
always.
It's a half a degree in the middle of the sky. It's a half a degree on the backside, front side, sun,
Not always.
moonrise. It is always the same size except for some orbital difference.
And the key
Which
thing
are
that
very
Matthew
subtle.
said, it was over the
Around a
period of
half a degree.
over the
Below,
period of a
below
night. Matthew
15
said it correctly.
degrees.
It doesn't change over the period of a night, but it does change according to the seasons. But that's a different issue. It doesn't change over
Below-
the period of a night.
Below 15 degrees is not recommended to use exactly for those situations, because of that. The angular size will change. It's too close to the ground. It will have atmospheric interference in it. That's why
George,
you
I
need.
feel like you're not
It's better
hearing what we're saying.
recommended.
We're not talking
It's
about
better
how high the moon
recommended
is.
to use the angular size of the moon or the sun when it's 15 degrees at least above your horizontal.
Correct.
Yes,
But if it's higher than
that's something
15
else.
degrees, then you can measure
And
the
why
moon's
is
size.
that? Because there
Even
is
Andrew-
atmospheric conditions interrupting it.
Even Andrew Thomas Young says there's atmospheric magnification going on.
And he
with
doesn't
things
say it's
just like this.
magnification.
Correct.
He doesn't say
He
it's
absolutely
magnification.
does.
No, he does not. It gets distorted. That's not magnification.
I've been in arguments with these guys where they told me that he doesn't understand how, or he wasn't using the word magnification. He definitely uses the word magnification.
Where? Give me a link to that.
I don't have it on hand. I've
He
had
does not
debates
use-
over whether
I've
he
never
knows.
seen magnification used on his website.
Okay, I've had debates with these guys over him not knowing how the word magnification works. So
Because a magnification is a magnification that's linear. In other words, it was stretched in horizontal size as well as vertical size. And he's never made that claim on
he
any part
has.
of his website. No, he
He's
hasn't.
claimed atmospheric magnification, Rumpus. He has. I've had debates with these guys over Him
Who's
using the
his
word
guys?
magnification differently.
No,
All your
he does
Glover
not.
buddies, Kosho,
No. Well, they must have
all them
well, you
guys
must have
at
misunderstood
Gem.
them. Moyak, Thomas Young does not, because that would require a horizontal increase in size and size, and nowhere does he claim that occurs. That's what magnification is, a uniform aspect ratio preserving operation. The things that occur when we talk about things going towards below the 15 degrees means that they can get compressed slightly vertically, only vertically. They're not changed. They do not change their horizontal size, but they can change as the sun. When you see some sunsets, the sun
Really?
gets compressed slightly. But
then
anyway,
why isn't
if we ignore the 15 degrees thing, that still doesn't change the thing that Matthew was saying, which is the angular size of the moon. If we ignore the very low angles, which get interfered with refraction, the angular size of the moon stays exactly the same, which it cannot do on a flat Earth with a local moon.
Oh, I see. So
Rumpus,
if we ignore the part when it doesn't correspond to what we're saying, once you ignore that, everything else is possible.
you wanted
Well,
a
in
link to that,
actuality,
Rumpus?
even in
Are
that
you
case,
for real, man?
Well, you wanted a link to it,
even
Rumpus,
in
real
that
quick?
case,
I just posted. That's from Andrew Thomas Young's website, Magnification at the Horizon. It's a whole page on magnification that he talks
Okay, well, he
about.
must be using it in a different term. They're not in the
That's
universally accepted term.
Thanks, Gio. Nice work.
George, we're not ignoring certain parts. We're just saying let's restrict the conversation to after the moon is 15 degrees above the horizon until the full moon is within 15 degrees of setting. So we're not ignoring the other times, just like we're
So you're correct in
not
your
ignoring the
statement, in
daytime.
other words. Yeah, I appreciate that.
it also only shrinks when it gets down there. It gets squashed. The horizontal width remains still. So it's refraction that's causing it, not some kind of magnification. Unless it's that loose one that Andrew Thomas Young is talking about. Magnification, shrinkage.
Okay, since we're continuing the conversation with Matthew, perhaps I will ask the question that was asked to him about the Artemis. You were asked about the two different speeds. The Apollo made it in 11 days? There was a difference in 4 days travel time, and you said it had to do with the orbital mechanics.
Right.
Can you elaborate on that?
I don't know much about orbital mechanics, but if you're wanting to bring up the idea of escape velocity, in order to escape out of the gravity well of Earth, you need to have the potential energy in speed, the kinetic energy in speed, greater than the potential energy in altitude or something like that. That's not a super good, precise explanation. But basically, you just have to go fast enough to get out of the gravity well. And then you can, if you're going that fast, that gets you out of the gravity well, but you can certainly go faster. So
Yeah, well,
perhaps
that
the Apollo,
involved.
the Apollo astronauts went faster than Artemis, but they were both above the speed required to leave the Earth orbit.
Were they?
Not exactly.
Just a quick on the magnification thing. Andrew Thomas Young makes it clear that he's referring to a vertical magnification, which is a rather unusual way of describing it, but he just talks about a vertical magnification. So he's basically saying what I'm saying, it's a compression only. But yes, for some reason he's chosen to use the word magnification, but he does qualify it by saying it's a vertical magnification, not what we would understand if you're using a microscope or something as magnification. I don't know whether he's got a strange use of the word magnification there, but he does say it's just vertical.
Come on, Rumpus, give it up.
I told you that's exactly what. Now we're arguing over the word magnification.
Yeah. He does make it clear he's talking about just vertical.
So speaking of the Artemis missions, I just have a general question for everyone who's listening. Did my explanation of how Newton's third law influences the fact that rockets can propel themselves in space, did that make sense to anybody? Because
Yes,
you explained it very well.
Yeah,
Actually,
we heard it 100 times, Matthew.
Yeah, I thought your little visual demonstration with your propellant actually was very good, because sometimes they don't understand. I think that the propellant, the exhaust, has mass. That's their problem, basically. And then one thing you could have done perhaps to make it better is if you could describe, if you were standing on a chair on an ice rink or something and you threw a bowling ball away from you, what would happen? You would obviously go in the opposite direction of the bowling ball.
Exactly. Okay.
Or fired a gun. Lots of big gun.
Yeah, you're not pushing off the atmosphere, obviously, when you throw a bowling ball versus a beach ball. Throw the beach ball while you're standing on ice, and you'll stay still unless you really throw that beach ball hard.
Yeah.
And you throw a bowling ball and just a gentle shove, and you're going to move backwards. It's not the air that's doing it. You're not pushing off of anything except for the mass.
And I presume that these flatties would accept that if you were in a vacuum in an icing rink and you did the same thing, it would still work in the same way. You'd be flung backwards if you threw the ball in the other
Yeah,
way. The air has
of
nothing
course
to
it
do
would.
with it.
Vacuum chamber on an ice rink.
Yeah, I know. It's a
There
bit,
you go.
you can actually have ice in vacuum. They do actually have ice on the outside of the Apollo mission sometimes. It will sublimate, but you can actually get ice actually in a vacuum. So yes, it is. You'd have to try quite hard, but it is actually possible. Though it will obviously start to sublimate.
Well, you can keep persistent ice in space if you keep it in dark. Keep all energy away from it, or at least most energy away from it.
Let's go find some in the craters of the south pole of the moon.
That's what they're talking about.
Keep
Yeah,
the fantasy alive, boys. That's it. You can do it.
So you now understand escape. As far as model saying about escape velocity, that the
No,
Artemis
I always
and
understood your
Artemis and Apollo never reached escape velocity going.
Yeah, escape
No need
velocity
to.
means you if you could
NASA
if you could
disagrees with you. Yeah.
if
You
you
have
could
that
throw a
link?
rock. No, it's just if you could throw a rock at 25,000 miles an hour, it would leave. It would leave the Earth's gravity. But that's not what rocket ships do. They propel themselves to their position. They don't have to go 25,000 miles an hour to go up.
Yeah, because
SC,
ideally,
do
what
you
you
have
want
that?
to do.
SC, do you have that article that I posted that night where they NASA themselves said escape velocity is crucial to?
Yeah, of course. I posted
to-
like 100 of them. I don't know if I have them now. Let me see, because I'm not where I usually am.
Unless
I
there's
was
another
crushed
use
on
for
that night on this. I don't understand why we're even still on this.
If you
Well,
had
escape-
far to the escape velocity from the Earth, you would end up the other side of the universe eventually, assuming it didn't hit anything. Whereas what you want it to do when you fire it up in going from the Earth and you want it to get to the moon, you actually want it to go up like a ball. If you throw a ball up, it gets up to a certain height depending on how high the velocity was. If you then throw it to a certain velocity, you want it to get just enough to get to the moon and stop. Or actually to get to the Lagrange point, the midpoint between the two, the Earth and the Moon, and then it would fall towards the Moon. And that does not require you to go to the other end of the universe, which is what escape velocity is.
That's a great explanation. Thank you.
If you were playing 10-pin
My pleasure,
bowling on
Matthew.
ice and you threw your bowling ball at the pins, you would go in the same direction as the bowling ball, not the opposite way.
What?
Say that again.
Say it
If you
again.
were playing 10-pin bowling on ice, you would go the same way as the ball once you release the ball.
No. If you were standing on a chair, on a chair, on roller skates, and you
Not on
threw
a
a
chair.
ball. Hold on, you're on rolling skates on an icing rink,
You were
something
no.
like
If
that,
you
and
were
then you threw.
if you
Hold
were
on, let me
playing
finish the
10-pin
scenario.
bowling on ice with your shoes on,
the scenario. You can't rewrite the scenario I described. And then
I'm
you
making
threw a
my own
bowling.
scenario.
Let me just no. Well, I'm making up one. You can't. Well, okay. We're talking about the scenario I made up, which is you throw a bowling ball away from you while you're on rolling skates or on ice. You will go in the opposite direction to the bowling ball. And if you come up with another scenario, then you're not commenting on my scenario.
Rumpus, you're assuming that you're starting at zero velocity.
Yeah, you're standing still on the
Of
ice,
course.
and then you're throwing away a bowling ball from you, and you will go
I think
back.
Carlos was talking about if you're moving already.
I don't even know what that means.
Yeah, please.
Jeremy, are these what you were talking about?
I don't know. I had one from NASA that said that the future of space escape velocity is crucial to the future of space travel or something.
Yeah, there's so
I don't
many
know
of
what
them.
they.
There's so many of them.
I mean, I've never heard it called escape velocity when talking about going to the moon. And maybe they could call that because you are going into the influence of another body. You're still in Earth's gravity. Basically, the moon is in Earth's gravity.
Like it was NASA.
Oh my bad. So escape velocity, as far as I'm concerned, is leaving the influence of Earth.
Yeah, they might be just
they
dumbing
may
it
have a
down for
different
the
use of
viewers.
it.
they probably just dumbed it down for some viewers so that if they had to explain it wasn't quite escape velocity, but it was something in between escape velocity to get to just so that it was rising up like a ball to get to the moon. They'd be spending about 2 minutes like I did on explaining it. Whereas if they got some dumb viewers, they're just going to say, "Oh, let's just call it escape velocity and have done with it."
Yeah, lunar
Can they dumb it
ejection
down anymore?
velocity.
Can they dumb it down anymore? You think?
Well, given the fact you
guys don't like words they're using. Hold on, real quick. You guys don't like words they're using like magnification or escape velocity. You're like trying to change the definitions of words and shit. It's weird.
No, they did. If you use the physics terms, then it's magnification. I mean, that is a strange one by Andrew Thomas Young. I don't know whether there's something in refraction because they go on about this stretching all the time. Perhaps they just drop the fact he did mention it was vertical, but perhaps they're trying to. Otherwise, you've got to keep on saying it's compressed or expanded. So I suppose perhaps he's right that so often.
Yeah. Remember the part.
Well, no, distorting can mean several directions. It's quite specific if you just say vertical magnification. He's just dropping the word vertical or something, or because he got bored or something, having to type in vertical compression or something each time. Just thought, well, we all know it's not going to stretch horizontally, therefore I'll just use the word magnification as a shortcut for vertical compression.
The Globers have to invent new definitions and be very creative.
We have to dumb it down for people who don't understand. If you use the physics terms, unfortunately, you don't understand things like escape velocity, because then we have to explain to you for 2 minutes what escape velocity actually is. Whereas if we just say it's the velocity to escape from the Earth, but there's a particular value if you want to get to the moon or go to the other end of the universe, that's too confusing for you.
Or you have to create a new science. That's why nobody can agree.
No, we don't create anything.
Neil deGrasse Tyson. You think there'd be a right and a wrong, but apparently there's a lot of debate. Maybe the science is not solved.
Listen to what they believe. Listen to what they believe. Go, Jeremy.
I was just going to say my favorite part was when Rumpus told me that he never mentioned anything about magnification, and now we're arguing about what the word magnification
Okay, well, he
is.
used in a different... Okay, I'll admit then I thought he wouldn't have done that, but I have never read that, I must admit that... Anyway, he refers to it specifically as just vertical magnification, which I think is a bit odd. I might write to him about that and say, this is being misunderstood by people. I do communicate with him. I will ask him to do something about that.
This is how they think of their escape velocity, Jeremy. Check this out. Picture a trampoline, right? Put a bowling ball on one end and put a smaller bowling ball on the further away. So you have two depressions, right? So for them, escape velocity is firing a rocket and leaving the brim of that depression, right? And once they start going up, they start slowing down. So once they leave the surface of the ball, right? They reach a certain speed, but at the same point, it's slowing them down. And once they reach the end of that rim, think of it as a soup bowl. Once you reach the edge of that soup bowl, right, you go to zero, and then you just go right over that rim, and then you fall into the other rim of the other bowling ball. And then you go down that soup bowl ridge. That's how they envision it, man.
Well, yeah. What's the problem with that? But also, the trouble is that's
what's
the
local
problem?
escape
Velocity.
Fantasy.
You see,
that's
the thing when we think about escape velocity, we normally take it to the other end of the universe. Now, you're talking about little local escape velocities. You could call those escape velocities, I suppose, if you're trying to get from one gravitational depression to another. But that's not really what word escape velocity is used for. It's to where it means that we've got sufficient velocity, like throwing up a ball, and a ball would just carry on infinitely going upwards. Just like a spaceship would carry on to the edge of the universe and would never come back to Earth.
The edge of the ball. It's also escape from what? Because escape from Earth does not mean escape from the sun.
Okay, before
escape velocity will not take you to the end of the universe. It'll take you to somewhere else.
I did mention without being interfered with by other things, but yes, you're right. Yes, you have to get round the sun escape. So it's a good point, actually, Mark. Yeah.
Did I explain your fantasy correctly?
Yeah. It's not a fact. No, what don't you understand about that? It's quite simple.
You mean what I just explained to you?
It depends on what you want to talk about the word escape velocity. But yes, that does. If you're prepared to talk about the word escape velocity as the value of the velocity you need to get up to the ridge, then yes, that does agree with what we've been saying. So what's difficult about that to understand?
No, it's not as hard to understand. I want other people to understand the absurdity of what you call space is.
Well, you're calling it absurd. That means you don't understand.
No,
You
I
seem to
understand it
understand it.
perfectly. I just want to make sure other people understand the absurdity.
Well,
That's
how's it
all I'm
absurd?
saying.
You've just said you accept it. So why is it absurd?
I didn't say I accepted it. I said I understand your fantasy.
Well, you
That's what I
understand that
said.
gravity exists. Why is someone making a coffee or something in the middle of this?
I'm sorry.
Right.
Makes me want a cup of coffee.
What do you got? A percolator?
No, I was trying to put a container back in the cabinet.
Wild
It's got some
West
glass
style.
things in it.
Is there pressure in that
if
container?
if you accept that the gravity is like almost like a spring, but just works slightly, it has an inverse value, then the further we go away from to get very far away from the thing that's on the other end of the spring, you've got to throw it with a bigger velocity. I mean, it's a really simple concept. The gravity pulls towards the center of the Earth, and that's why balls come back to the ground. So the same thing that satellites come back to Earth if you don't fling them away quickly enough.
I thought of an
I just
example.
want to make sure, because I had this conversation with Blue, right? I just want to make sure that that you guys understand that we understand your fantasy, right?
But you don't
It's just
understand
that
it.
we don't believe it. It's not that we don't understand it. We can explain it to you in detail, right? Like I just did.
But the
But
behavior
it's
you've
just
just
that
described.
we don't. Rumpus, why do you interrupt all the time, bro?
Go ahead.
It's just that we don't accept your fantasy. It's not that we don't understand it.
Right, but if you accept there's a force attracting towards the Earth, then that immediately follows what you've just described as a necessary consequence. If it's an inverse square law, it's a necessary consequence. The rippling you just described on a depression in a trampoline type thing, that's a necessary consequence of having an attractive force to the Earth. There's a certain velocity that will take you away from the Earth's influence, and if you don't go up to that velocity, then it'll come back just like a ball does when you throw it up in the air. What's the difficulty?
Yes, if you, Rumpus,
Can you
if
measure
you
the
believe in that,
attraction?
if you
Sorry,
believe
can
in
you
that,
measure? Oh, you go.
I'll just say one thing and I'll back off. If you believe in that fantasy, Rumpus, which I explained to you and which I told you I don't believe, yes, then things might work in that such a manner. But that is a fantastical, non-provable thing you have. It's just a story.
You can jump out of a window and you can experience the same force as a subjection to a satellite. So you've got practical experience of it.
Can you, Rumpus? Can you measure the force of gravity directly between the sun and the Earth? A direct measurement.
Well, if you were to not have an orbital velocity, so we're going around the sun at 67,000 miles an hour, whatever it is. If you were to leave something in space that was not going around the orbital, it would then accelerate towards the sun with the force of gravity. The fact that we're orbiting it insulates you from that effect. Effectively, you're in free fall, but you're free falling around in an orbit. But you don't experience a force. But if you just let it, if you were not going at that 67,000 miles an hour, you would have a force going directly towards the sun, and you could measure it.
There are a lot of assumptions there. What about the direct measurement between the Earth and the sun? The gravitational measurement.
I just told you, if you could, we're going at 67,000 miles an hour. If you could switch that off, if you could set a satellite up, launch one, and then remove the 67,000 miles an hour orbital velocity around the sun, you could then measure the force that's pulling on it towards the sun. And obviously, all the calculations, the orbital calculations we've got for when we got the Solar Parker probe there at the moment, and the acceleration that we had to remove that's what they did. They had to remove the orbital velocity of it, and then it was accelerated towards the sun. And the calculations that you end up, the orbits that you need to understand what the force of and the acceleration towards the sun is, and the fact that we've been able to park a satellite around the sun relied on us understanding what the force and acceleration towards the sun is. So we have in effect proved it directly.
I have a simpler answer. I would say if you're asking about if we have directly measured the force between the sun and the Earth, the answer is no, we have not directly measured it, but we've calculated it, and I think that's good enough.
If there was gravity between the Earth and the sun, wouldn't my hair stand up at high?
No, because you're in free fall. You've got an orbit of 67,000 miles an hour around the side of it, and that eliminates you in free fall in effect, and that you need to understand about orbits, and that effectively
So the sun
insulates
is
you from
not
the effect of
pulling.
gravity. Oh, it is pulling you. Oh, yes.
Not pulling on me.
Oh, it is pulling on you, and it's pulling on the Earth just as much. But the point is, you've got an orbital velocity of 67,000 miles an hour, which is preventing you going towards the sun.
So, high noon or nighttime is no different. My hair is going to stay in place.
Yeah, look, you understand centrifugal forces, don't you? They push you out. Well, the orbital velocity is making you go out, and the centripetal acceleration of the sun is pulling you in. Those cancel out, so you do not feel any forces.
There are tiny differences. That's what makes the tides. So can I ask
down to the moon? Mostly
can I
down
ask
to the moon. Yeah, when the sun actually rotates, you are very slightly closer on one side of the Earth than you are on the other. There is actually a very slight differential, which you can actually measure. So you wouldn't be able to sense it because your sensors are not strong enough. But you can actually measure the difference between the gravitational force of the sun on one side than the other. So you can actually measure it directly. Actually, so when we were saying earlier you couldn't, there is actually an easy way. When the Earth is pointing towards the nearest point of the sun and the other side of the sun, there is actually a slight difference in force acting upon you. So
you could say that you weigh less at noon than you do at midnight.
Slightly.
Yeah.
Can I measure curvature?
220 at midnight, 221 at noon.
It's not going to be that
tiny.
much.
Just like we can only just about measure the difference between the equator and the pole. That's a 0.3% difference. The difference between one side of the Earth and the other towards the sun is actually much less than that. I think it's something like 1/20th of that.
Can you also say it's negligible? Can you also say that?
Yeah, as far as you're concerned, yes. As far as you're concerned in your life, it's negligible. But we can measure it with very careful instrumentation, high resolution instrumentation. We can measure it.
Could I ask, say, Montreal a question to go back a little bit? Would that be okay?
Sure, go ahead, bro.
Yeah. So you said that you understand our model in maybe even better than most globers. So I was going to ask you, what did you think of my explanation about how rockets can propel themselves in a vacuum? Do you think that is an adequate explanation, or how would you say? Again, I know you don't believe it, but how would you say in our model rockets move in a vacuum?
Well, yeah, I know how your model explains it, and I heard you explain it, right?
Right. Do you think it's an adequate explanation?
Personally, I don't think so, because I'm of the opinion that I think the thrust has to push against something, right? And even when you see the rocket, like, I'll give you proof of why I think that, Matthew. You've seen the rocket launches, right? Spectacular event, right?
Right.
And that massive amount of firepower that comes out, I don't know how many millions of pounds of thrust, right?
Right.
Now, you are aware that they throw water in that cavity before that happens, right? Or else it would destroy...
yeah, because it's so hot.
Yeah, in the launch pad, in the cavity where the rocket is.
Right, they'll destroy the launch pad if you don't do that, right?
Yeah, correct. So that goes to show you that a rocket it needs something to propel against, right?
So then shouldn't it go slower the further it gets away from that?
Why are you cutting in? I thought Matthew was asking. Why are you cutting in?
Well, I figured you answered an interesting question.
Okay. Well, you could have at least waited until I finished, right?
Shut up!
Amen?
Okay, so can I respond? Are you done?
Yeah.
Well, I guess I made my point.
Yeah, so I understand what you're saying, and I think there might be some slight effect to pushing against the air at some point. I'm not sure. However, the fact that you said that you don't think that there could be the rocket could push against the vacuum, or I mean, the fact that you don't think it would work in a vacuum, to me, is evidence that you don't understand our model as well as we do.
Well, I started off by telling you that I do, and I understand your explanation. I mean, your model, you say that it pushes off the rocket itself, right?
It preserves the center of gravity, and so the reaction of the exhaust going one direction is equal by the reaction of the rocket going the other direction. That's Newton's third law.
Yeah, but you need something to push off of, no?
You do not, no.
You do not need something to push off of.
No, just like the Rumpus was saying, if you're sitting on a chair in an ice rink and you throw a bowling ball really hard.
In fact, as far as I'm concerned, the rocket thrust decreases the closer you are to the ground. You get less thrust because you're fighting against the atmosphere. The exhaust velocities are slower because they're pushing into a higher pressure area. If you were in space pushing the same amount of thrust out, or the same amount of gases out, they would come out with a higher velocity because they'd have fighting them.
So the way I see it, it'll just go around in circles at best in space. That's the way I see it, like a balloon going around in circles.
That's only because the orifice on the balloon changes direction.
If it moves.
You're just ignoring the bowling ball for scenario then I've described to you.
Yeah, but when you throw the bowling ball, right, it's pushing against something, no?
No, you're pushing against
the
bowling ball. The bowling ball goes away from you, and you go in the opposite direction to the bowling ball. It's very simple.
Right. And if you were to do that in a vacuum, you think you would get the same reaction?
Yeah, the rocket is pushing against the exhaust.
I'm not so sure of that, because I've seen tests of rockets, right, in vacuums, and the ones that are not confined in small spaces, that, in other words, meaning when you fire the rocket, the gases could push against the wall. The ones that are far away, the rocket doesn't go nowhere; it just stays there.
No, they don't. Well, sometimes they fail, but yes. But if you just concentrate on my scenario with a bowling ball, then you can get the principle sorted out, and then you can worry about whether people have done it properly.
Yeah. Don't try to down talk to me. I understand about your bowling ball scenario,
well,
but
you didn't seem to
we're
understand
talking.
it.
No. I gotta see this in a large scale scenario, because, like I told you, I've seen videos and both things happen. Right? I've seen rockets
but as I said, that's an
that do
experimental
move.
issue. That's another issue. That's a complication you're adding. If you just deal with the principle, if you understand by conservation of momentum that when you throw a bowling ball away from you must go in the opposite direction if you're a free moving object, and the same will happen in a vacuum.
No, we understand your bowling ball. We ain't
But
talking about bowling
you
balls
don't understand
now.
about the
Take
conservation
the
momentum, otherwise
bowling
you wouldn't
ball
be
out your
disputing it.
mind, Rumpus. We're talking about an actual demonstration in a vacuum chamber with a rocket. Take the wax out of your ears.
The bowling ball thing
Let me
works?
finish my sentence, Rumpus. I told you I've seen both scenarios.
Right, but do you understand the bowling ball scenario?
Oh, I give up, Rumpus. I ain't talking.
Yeah, but you're not answering my question. You're avoiding my question.
Excuse me.
Do you understand that in a vacuum
said he
chamber
was
and you were
done.
on a slippery ice and you threw the ball on the wall, you would go in the opposite direction?
Yes,
Do you understand that?
Rumpus.
Excellent.
Yes.
We've got someone.
Okay, now back to the rocket scenario, Rumpus.
Right, and the rocket scenario has got the same principle. It's
that it
throwing
could
stuff out.
happen, oh my God, forget it.
Yeah, but if you understand that principle, you must understand if there's mass in the exhaust, then the same thing must happen.
Thousands
I'm going
of
to
pounds
try
per
one
second.
more time, Rumpus. I'm going to try one more time, and then I'm going to go on mute.
Yeah,
I
Rumpus,
know
we don't want to.
it's absolutely useless talking with you.
No, I was just going to say, ideally, yeah, Rumpus, we don't want to have to mute and stuff. So if you could just let him completely say his full thing.
Well, I've got to go to bed anyway, so I'll leave you. Thanks anyway, June. I've got to go to bed anyway.
Good night, Rumpus.
Yeah, I gotta say, Rumpus was being worse than USC, but you were interrupting everything he said also.
Yeah, but you can't get a word sideways in with him, Moyak. You know that.
Like I said, he was being worse, but you were interrupting quite frequently.
Hey,
Well, there's no
Montreal,
other choice with Rumpus.
don't you imagine if like a grenade exploded in outer space, shrapnel would go in opposite directions of each other? Like that's fair,
I would
right?
have to say yes. Yeah, I would have to say yes.
Ooh, I like that analogy.
We're talking about
it'd be the same thing on Earth, right?
Yeah, but we're not talking about that. We're talking about
It's kind of the same thing.
Wait, but it won't be sound because sound can't circulate in vacuums, right?
And if you put a hand grenade inside of a tube, and it could only explode in one direction in space, what would happen?
Well, let's say
Why
there's
are we
two.
talking hand grenades, tubes, toothpaste?
It's an explosion,
like a rocket launcher.
Why don't we
the rocket? I mean,
the actual thing that we're
wildly
talking
like
about?
a balloon.
The thing about rocket propulsion is it's like a constant explosion coming out of the ass of that rocket, pushing the rocket. That's what that's what the rocket's doing.
Maybe we can write a poem about it. Maybe we can write a poem and say some verses, or we can actually do a test, right? And see how it works. Now, I keep telling you guys, I've seen both things. I've seen both things happen. So for me, it's inconclusive. I want to see a big rocket in a big area where it doesn't have the ability to push against the wall.
Can you show me one of the fails? I don't recall ever. I don't
Wrong.
recall any rocket not progressing in the vacuum chamber, except for the ones that didn't ignite. So do you have an example of one that lit and didn't progress?
Yeah, of course. I don't have them at hand. I mean, I haven't talked about this in I don't know how long, but I can dig them out if you like.
You need an atmosphere to push up, otherwise you wouldn't go anywhere. Just logic.
That's not logic. It's defeated logic. We've shown rockets inside a vacuum chamber is working, although there's a little question is that what SE says he's seen, and I haven't seen that yet. So
the guy left said rockets shoot mass, but that's not really true because the rockets they unload the bulk in the Earth's atmosphere, and then they're just out there sailing like with nothing, with no more mass to shoot out, right?
That's true. Well, except for the little bit they keep maneuvering.
Yeah, look, Moyak asked
maneuvering, right?
I got a question for the Globers.
The rockets that you see, Moyak, they were in confined spaces, no? Say the truth.
Yes, of course.
Okay, so it's not really conclusive, right? If you want to be honest with yourself, it's not a conclusive test.
Well, I don't see any. Having an understanding of physics, I don't have a problem with that thing, that nuance that you're talking about.
So you don't understand.
You want to say that if you want to say that nuance has some effect on it, then you'd have to explain that. I have the rockets that I built from scratch. Building them, my own rocket fuel and everything. They take 1 ounce of fuel and shit it out through a little hole at thousands of feet per second, and the rocket goes the other direction. It's inevitable. It has to happen. Whether it's in a vacuum or not.
Moyak, if it happens, it happens. I won't die on that hill. I'm simply saying I want to see a test where it's not in a confined environment. Well, I will be satisfied that it's not thrusting against the wall. That's all I'm saying.
Well, what is the distance? I would like. Since you're the one who's defining this, and what is the distance you would need it to be away from the wall?
I would like to see it in the Sandusky vacuum chamber, like on a pinwheel or something like that.
Yeah,
exactly. That'd be cool.
Yeah.
Right in the center. We should have that by now, really.
Yeah, a little rocket.
That's a great idea.
Very good idea. That's exactly what I was thinking, Left Lane.
Yeah. Nice, love. Hey, I got a question for anyone who might be able to help me. I want to do some